If that is so, then we can take PL and ma'am will take care of it. We completed only one of the yes, yes. Yes, yes, yes. If you are going to the desire of completing it completely. So after that,
Good morning, everyone.
give
I'm Smita SP, Assistant Professor, President of the School of Computer Science and Engineering. It is my pleasure to welcome you all to day 3 session of the AICTE ATAL VAANI workshop on application of artificial intelligence in medical image processing and data science, organized by Presidency School of Computer Science and Engineering. Today, we are truly privileged to host an eminent expert in the field of computer vision and machine learning, Dr. Chandrasekhar Badu, who will be delivering the session. Dr. Badu is a dynamic and highly motivated researcher with over a decade of rich experience spanning both corporate and academic sectors. He holds a PhD in computer vision and machine learning from NIT Circle and MTech in VLSI design and embedded systems from BTU Belagavi, and a BE in electronics engineering from SRTMU Maharashtra. Professionally, Dr. Badu has served in pivotal roles across leading technology firms. He has worked as technical lead at Continental Autonomous Mobility, member technical staff at HCL Technologies, project intern at Electronics, and project training at LSIR and B Private Limited. His corporate journey reflects deep technical expertise and a commitment to innovation in emerging technologies. In parallel, Dr. Balu has made notable contributions in academia as an assistant professor at reputed institutions including Dayanand Sagar University, SPERI College of Engineering, Gopalan College of Engineering, and New Horizon College of Engineering. So, it is an honor to welcome you for today's session. On behalf of the organizing committee, the management, and all the participants, I extend a very warm welcome to Dr. Chandrasekhar Badu. We look forward to a highly engaging and enlightening session ahead. Welcome, sir. Thank you.
I hope it's audible that you have. And you can have the microphone on. Yeah, it's on. Alright, so thank you, ma'am, for the kind introduction. My name is Chandrasekhar, and I've been currently associated with Siemens Engineers for the past 2 years. When Shivram sir approached me for a talk, I was obviously working in academic along with Shivram sir quite some time, maybe like 2-3 years. But then when he approached me for a talk, I was like, "What topic do you have for the workshop?" And then he suggested it's all your field, whichever you work. Then I was a little hesitant because it's been a long gap that I was not giving any presentations since I was working in company. But then it's always good to stand on stage and talking to people and sharing our knowledge. So thank you for accepting my invitation. So for today, we'll be mainly focusing on OpenCV. Okay, so maybe I can show you the agenda. We'll start with the overview of OpenCV, like when it started, how it evolved, and what are the algorithms present in OpenCV. And later we will see how to set this up onto your systems. It could be either Windows, Linux, or any Mac OS operating system. Then we will also see few of the basic operations which we can perform using OpenCV library. It could be either operations on the images or could be operations on the videos. And then we will see some of the the advanced applications of OpenCV, for example, image registration or image encoding. I have limited this fourth topic only to the image registration and encoding, but however, we can explore more because this OpenCV is an open community where a lot of people every now and then they voluntarily support for the expansion of the OpenCV library by contributing to the same requirements. Then we'll also see how do we do the video processing. Most of my talk will be specifically to the image processing, but then we can also extend this image processing talk to the video processing. It's just that we need to be more time constrained because whenever we are performing any task for video, we have to keep the time into mind because per frame we have to process within milliseconds. Okay, only then it will serve the purpose of video processing. Then we'll also see some of the resources and communities wherein you can, for any particular doubt, you can obviously go to these platforms or open source, post your questions and get the answers. Okay, it's a very rich community of volunteers. So, with this we can start. So when I say OpenCV, it obviously you might have heard of this terminology OpenCV. Uh, the CV stands for computer vision, and when I say computer vision, it's basically a field of artificial intelligence. Now, what you understand by computer vision is that it's the ability of the computer to understand the images. Whenever we fit a camera to the computer, it basically looks into the environment and tries to capture the information from the scene. Now, just by capturing the information from the scene is not sufficient, right? The computer has to make some certain kind of decisions. Better? Yeah? Okay. So, yeah, so I was telling, so computer vision basically is a field of AI wherein you allow or give the ability to the computer to look around in the scene. Either it could be through the cameras or could be through other sources, could be audio and everything. But then, how do you actually access that information and make some decision on whatever detections you have done? Okay, so a whole lot of these things comes under computer vision. So it's the ability for the system to detect the information in the images and take some critical decisions. Um, so this picture you can see here. It looks like a computer, but then it also has an eye where it can gaze around and look into the environment to sense the information and make some critical decisions. We will also see how this critical decision happens into the algorithms at a later point in time. And this is also kind of a scenario where you give the human intelligence to the computer. For example, whatever your eye or human eye perceives in the environment, a similar kind of analogy you can say that the computer also is able to look into the environment and visualize the things. Alright, so as I said, OpenCV, it's a computer vision library which is very much rich in algorithms, and there are a lot of people who contribute to the development of the algorithms into this OpenCV library. And this is an open source. So open source means what? This is kind of an algorithm, or you can say a package, which any one of you can download it for your own personal use. And if you have some idea in your mind, you can develop your ideas on top of these algorithms already existed, and you can also redistribute it. For example, if you want to make a startup and you want to use the OpenCV as a stack, you can obviously use that and then build a algorithm or your idea on top of the OpenCV stack and then sell it as a product. Okay, so this is kind of an OpenCV library which is open to open source. And this is specially designed for computer vision and machine learning applications. In computer vision, there are actually three levels of hierarchy. You call it as a low-level vision, mid-level vision, and high-level vision. So when I talk about a low-level vision, you can almost think like a child's eye, wherein a child, when it looks into the world, it always sees some kind of high frequency information. For example, if a child looks into this classroom, it would only see some edges, corners, and something like that, which is very abstract level of information for the child. Okay? So that is all nothing but your low level information or low level vision. When you talk about mid level vision, it is something which is more higher or less abstract than the low level vision. For example, when four edges combined together, it forms certain kind of a shape, right? Maybe it could be a table or a computer. So those kind of information detection, we call it as a mid level vision. And in the higher level vision, you can also call it as very fine-grained information which a computer can visualize and see, which is something like a face or something like the whole body of any object or could be anything. Okay, wherein the details are more different. So these are the three different levels of vision which are there in the computer vision stack. And machine learning applications. This is again a field of AI where uh, your machine is capable of taking any critical decisions and informed decisions and provide it to the users. For example, if a robot is, let's say a robot is again a machine, right? So if it has some set of eyes installed or cameras installed on its head and it is allowed to walk into the room, so it should see where is the obstacles on its way. Okay, and based on the obstacles, it should find its way from the starting point to the end point. So those are the informed decisions which a machine can make, and the way we train these machines is by a lot of corpus of data because whenever a child is born, when you show some picture to the child, for example, an apple or orange, it will not be able to recognize it, right? So we have to tell the child maybe 100 times or 1,000 times by showing the same picture or a variety of such pictures that this is an apple, this is an apple, this is an apple. So when you ask him 100 or one time or 1,001 time that what is this, it will be able to recognize. Okay. So all these machine learning algorithms are very data hunger. For example, to train any particular machine learning model, you need to have a lot of data. And OpenCV is especially the tool which is built only for images and videos. You can use it for audio, but then I'm not really sure, never worked on audio things, but probably image is nothing but a 2D, and when you say video, it's nothing but a kind of a 3D because you have this 2D image and the third dimension will be your time. But then when you talk about the audio, it's just 1D. So maybe all the algorithms which are available, maybe you cannot directly use them, but however the logic built for image and the video can be used for audio. And it contains almost like 2,500 algorithms. We will not touch upon all of these, but fairly we can look at few of the algorithms and we can have some hands-on in the segmentation. Okay, I won't spend much time here because we are already we have time till 10:30, right? Okay. So this is just the information on OpenCV. This is run by a non-profit organization called Open Source Vision Foundation, and it was first started by Gary in the year 1999. Okay, but then this was just a lab setup wherein he was trying to access the information from the image, but the first release into the market happened in the year 2000. Okay, that's when it got popular, and all the research community have noticed the usefulness of the OpenCV and its usefulness, and that's how it became popular, and more and more people have joined this non-profit organization. And this OpenCV has a support for variety of programming languages. For example, if somebody is expert in Python, they can still work on OpenCV. Or if somebody is not expert in Python but expert in either C++ or Java, they can still work on Python. They can still work on OpenCV. Okay, so it supports multiple languages. The logic remains the same. The function call for the modules inside this OpenCV library will also remain the same, but only change what happens is between the syntaxes of the function call. For example, all of you might be aware about the Python programming, right? It's just like a very high abstract level programming language. which just understands some English like language, right? It just say print and then give some string, it just prints it. But whereas in C, you have to include the library, include hash, include IO stream, hash, include all the other header files, and then you have to use the printf scan statements to print the string, right? So does not matter whether you are coming from which programming language, it supports multiple programming languages. Also, it supports varieties of operating systems also, like Windows, Linux, iOS, and Android. And the current CEO is Dr. Satya. Maybe I'll show you a link, OpenCV link, where you can directly go and check the organization link. So it's better always to know the CEO because the first message on the homepage will always see. Okay, so these are few of the key features. Although the list is very short, but it can go along. Um, so these are the points which I have mentioned only specific to the image processing. Okay. So here there are numerous algorithms for image processing. For example, filtering, which is again one of the very popular pre-processing technique in any of the model which you build. Even if you see the Gemini model, LLM models, or any of these large language models, whenever they get some raw data, there is always a filtering steps which is involved to get out to get rid of all the outliers in the input data. Similarly, we have this filtering stage in the image processing also. For example, whenever you are capturing any images or raw images, there will be a lot of environmental noise which gets into the image while recording or capturing. So it's always an important step to filter it. Next is transformation. You again have to transform it into your desired format. It could be a grayscale or a RGB or any other color space. This is with respect to image processing which I am telling. But you can also have the transformation in terms of the raw data to be in the form of a table or numbers. Okay, for example, if the data is coming as a float numbers, you can convert them all to be integers. And then few of the algorithms are there for text detection and then image manipulation task, and we will also see few of them in our hands-on session. This OpenCV has a very good feature of integrating the machine learning algorithms also. For example, object detection and recognition. Many of you might have heard about the popular object detection algorithm YOLO. Okay, so currently YOLO's latest version is V8. But then it all started from YOLO version 1, 2, 3, and so on. If you start creating the same algorithm from the scratch for the object detection, the YOLO algorithm, since the paper is already there, you can start writing the code from the scratch. But however, you may not be able to get the actual output what the paper or people in the paper have published, right? So we already have a ready-made package or a module inside this OpenCV library where you can directly use them and then process the image and get it out. Okay. So it is as convenient as using just like a plug and play kind of a component. And it also helps. It also has these algorithms for image recognition. For example, you want to detect any facial expression or could be sentiment of a person in the image or a video. So all of these libraries are there in the OpenCV. And this I have already told that it's multi-language support. So this is the OpenCV.org is the website where you can go and check out all the details. Since this is a library, OpenCV is just a library. So uh, until unless we go over the computer and experience hands-on how to access the modules from these libraries, etc., you will not get the real feel, right? So, however, I will explain all of these small little things which are available in OpenCV, but obviously, the more hands-on you do, the more sense it makes. Next is you have the C++ version of these OpenCV APIs, that is CV2X. CV1X is actually deprecated because it was all written in C, but now recently C++ and Java are more faster is what they say, and then it has been replicated. But however, C++ API is nothing but a superset of C API itself. If you are proficient in Python, you can use the Python API, that is OpenCV Python. You'll also see, since we will be using Google Colab, so you don't have to really install anything. But however, if you are working on some real project where you have a lot of folders and a lot of data to access, definitely Google Colab would not be a good option. Google Colab is just like, maybe you can still try, but then the dependencies will be more and the runtime will also be more. So yeah, if you're working on a bigger project, you definitely have to go with installing these packages on your computer. Few of the applications like face recognition, automated inspection and surveillance. You can all imagine this as a few of the applications for OpenCV, which act on images or videos. Okay. So, for example, people counting in a shopping mall who's walking inside the shopping mall, it can keep a head count of how many people have walked in and how many people have walked out. It's all just the processing of the input images itself. And also vehicle counting on a highway. For example, I have told you about the object recognition, machine learning package integration using OpenCV. It can use the object detection as a vehicle environment, and it can also track the vehicles and also count the vehicles and so on. And anomaly detection in manufacturing process, image stitching. This is again another algorithm where you have this panoramic view. That means you take the pictures from different angles and then try to stitch them together to give you a feel of panoramic view. So this is another feature which is available in OpenCV. Autonomous vehicle navigation, for example, if any object comes in front of you, how do you actually apply the brakes and so on. And object detection and how it can be used for medical maintenance. There are many more, but just to list a few I have mentioned. Setting up OpenCV, I won't spend much time here because since we'll be using Google Colab, but just for your information, we can set this up onto any of the operating systems, could be Windows, Linux, or Mac OS. And doing it on Windows, obviously, like all of us are much familiar with working on Windows operating system. You can directly go to the opencv.org website, download the package, and then install it. Similarly, doing it on Linux system, you can also use a few of the popular package managers. For example, you have pip, or there's one more called UV, which proposed to be 10 times faster than pip. So any of these package managers you can use and try to install these packages, these libraries. Similarly, on Mac OS, there is just like a package manager on Linux, you have the script and UV. There is something called as home view on Mac OS and try installing the library using this package manager. Won't spend much time here. Okay. So assuming that you have a Windows system and you want to work with OpenCV Python, assuming these conditions, I would say once you have installed it, you have to finally check whether this has been installed or not. So, firstly, you should have a Python package on your system. Secondly, you should have the pip or a UV package manager, which ultimately will fetch out the library from the sources and then tries to install it on your system. Once you have these two things, you can check which versions you have, whichever Python 3 or 3.10 or 3.12, anything is you can use that. Then use the pip install command to install the OpenCV file. Once it is successfully installed, sometimes there could be conditions because of some dependencies it may break, the installation may break. So you always have these steps to check if it has properly installed or not. So these are few commands, just like cv.__ version. You can check if it has already installed or not. All of you are comfortable with import statements. Okay, so CV2 is basically the package which will be installed in some of the /lib/bin folder. If you want want to rename it or you want to use a appropriate alias name to that, you can say that import CV as import CV to as CV. So in any of the following statements in your program, you can just use CV. CV dot call the method. CV dot and answer. Okay, so once it is installed, you may have to install your favorite or whatever IDE, the development environment. It could be either your Visual Studio Code or the Python. So these are just the IDEs just for your GUI purpose that you can call in the folder, upload the images, run your Python codes and so on. In the background, it will be calling all your libraries. Alright, so coming to the main points here, that's the basic operations with OpenCV. Okay, so whenever I talk about image processing, the first thing which comes into our mind is obviously how do we read the image first, right? So this is something like learning hello world of any program. When you have learned hello world of C programming or C++ programming, you might have written hash into your IO stream, and then the first line is main function, and then let's say print hello world, something like that, which is nothing but just a basic lines of code which would execute your program to see if all the installations and dependencies are correct. So in a similar way, to have the OpenCV working and using it, you first have to read the image. So that is done by the inbuilt function called imread. Now this is again a method which is available inside the OpenCV library. You simply cannot call imread; it has to be supported by cv.imread. Okay, that's how you call it. Once you have read the image, you want to display it. You have the function imshow, and once you have displayed, let's say you want to do some kind of a processing on the image. For example, maybe crop the image, or if the image has some noise, you have to denoise the image, or some other operation. Maybe let's say you have some marks on the image, you want to repaint all those marks and make it better, visually plausible. So after all these operations, let's say you want to save the image. Now, which function you use? You would use imwrite function. Okay. So these three functions are very popularly used in OpenCV because you continuously have to read the image, display the image, and write the image. Sometimes you have to also convert to a different color space. Most of the time you will be dealing with RGB image, but then there could be a situation where you have to convert it to a hue saturation value or any other color space, like for example grayscale, or it could be a binary image and so on. Okay. Image transformation. You can resize the image. Maybe for example, if you want to shrink the image, you can do it. If you want to expand the image, you can do it. So there are functions available for resizing also. Since we will not be going into the details of each of these algorithms as such, however, we will only see the functions or the modules or the methods which are available inside the OpenCV library. But it is always good to go back and check the foundation of these algorithms. I can just say cv.resize and give the input and say by half. It does my job, right? But you really have to know and understand what is happening in the background. Although most of the information will be abstract to us because we will be directly using these methods from the OpenCV library, but it's always good to understand the logic behind all of these methods. Similarly, rotation, flipping. So all of these image transformations we do to understand the image more and extract the information from it for a better decision. It supports most of the image types. For example, .pmp, JPG, PNG, WebP, and DIF. So all of these are different extensions for the image. You can use images with different extensions. Okay, so this is one such example to show you how do you read the image. You have the package, you have the library CV2, and you have the method IMB, and then inside the package you have to provide some information, right? The parameters. The first parameter is nothing but your path. From which location are you reading the file? okay, or are you reading the image? So that particular path could be absolute or could be relative. Absolute means if let's say for example you have stored it somewhere in C drive slash my folder slash dataset image slash image one. So that will be the real path. But if let's say you are already inside the data folder of my images, you can directly use the relative path and then exit. Okay. We can see a few examples. Maybe you can try your hands on when you are in the second section. And the second argument is the flag, which tells you how do you want to read this image. Do you want to read the image as it is in whichever format it is, or you want to read it into the RGB format, or you want to convert and read it into the grayscale format. So you have these multiple options. So few of these arguments you can use it as CV2 IMP underscore color to read the image as color. Otherwise, dot grayscale is to convert whichever format it is, it just converts into grayscale and read it. Or else underscore unchanged means you just read it as it is, no change in the image. Okay. So instead of all these alias names, we can also use these integers 1, 0, and -1. We can also see this more into our practical sessions. And yeah, so once the image is read, it returns an image. So ultimately, you have to save it into some of the variables, and it will be in the MAT format, matrix format, CV matrix format, or 2D, 2 dimensional. Now next comes the display of your image. Now once you read the image, you have to display it. You have the function called cv2.imshow. Now this is again something fancy. For example, window name. You really don't really care about what the window name is, but then you can still use this option of window name. For example, if you are displaying three such images, one is the input image, second is the processed image, and third is let's say the crop image. And then maybe if you are not able to distinguish which image is what, you can obviously use this window name to show what this image is represented or what is the image significance. You can mention that it's a string parameter. And the second parameter is the image itself. So whichever variable you have used to store the image, you can use that variable to. So you can pass this as an argument to the IMShow function. So our written here window name should be a string, and the image is nothing but your CVMAT data type, which is nothing but a matrix, a 2D representation. That should be the second argument. These are very basic, but yeah, since it's a starting, maybe you can. Next is writing an image. You have to, after processing all of the information in the image or video, you have to write it onto your hard disk. So there is a function called IMWrite with first argument as file name. For example, where do you want to store it? Again, it could be a relative path or an absolute path, followed by the variable or the CV .mat format, and that will be stored into your hard disk at a given file name. And yes, the return type is true only if it saves successfully. So it's always good when you are trying out things on your own. You don't really care about what is the return type, but it's always a good practice to handle all the exceptions in your programming languages. So this is one of the ways by which you can handle the exception. For example, if your writing has failed, if the writing of an image onto your hard disk has failed, you should always check its return type. If it's only true, then proceed to the next step. Okay, so these are few of the statements putting together the operation of reading, displaying, and writing the images onto your hardware. So you first start with importing the package. That's import CV2 as CV. Second is you have your image stored somewhere, you try to read it, and the second argument here is IMP color, which tells that you are reading the image into the color format. Third is IMShow. So this particular string will be displayed on your window, whichever window is popping up to display your image. it will have the title as display show, and ILG will be displayed. Now, there is one more option called wait key. This is a statement, or you can say a method, which waits for the user input infinitely long time until unless user presses some key, the window will remain open. Okay. So 0 means it waits until the user closes. And finally, you can use the destroy all windows command to destroy all the open windows there. This generally we use it when we are trying to open up multiple window screens with images, which are either your input images processed or the output images. So you don't have to click close to all the windows every time. You can just use this command to close all the open windows. And then finally you can write it to a particular this is related to image cropping. For example, whenever okay, you can just take the example of a number plate reading. When you are trying to capture a number plate of any vehicle, it could be that you are capturing a bit more extra space around the number plate, right? So that's when you need to actually crop the exact region of interest where the number plate is located. So there are few more situations where you might need the image cropping. So there are few logics which you can use. For example, okay, this image is a variable of data type cv.mat, and which is nothing but a 2D dimension. And in the square bracket, you can give the width and the height number. Only that much portion of the image will be cropped and saved, will get saved into your variable. Now, at the receiving end, we have started. I can use this. Is this so yeah.
If we would like to track the speed of any vehicle,
Sorry.
if we like to track any speed of the vehicle, by the image description we can do it. By identify the image description, can we speed the track?
Only the images you cannot do. You definitely need successive images.
Yeah, that is what I'm asking.
Yeah.
And this is by the image we can identify the
Yes,
speed
you
of the
can.
vehicle.
You can always, because velocity is speed by time, right?
Yeah.
Yeah. So by using the key dimension, you can see when was the frame first captured and when was the
Second successive frame.
next frame ever captured. Based on the time, you can have a okay, so this is what image cropping. You can give the dimension of let's say x comma y. So sorry, width comma height. Then which portion of the image will get cropped and will be saved in this. Now here on the left hand side, I have three parameters E, G, and R. If most of you have worked with MATLAB, you may experience it little reverse, because in MATLAB, whenever you are trying to read an image, the first channel will be always red, then green, and then blue. But here it is reverse, it's blue, green, and then red. Okay, so this one precaution you have to take care if you are familiar with MATLAB programming. So here, I assume that the image which I am reading is a color image, and when I am trying to crop it, it tries to crop the dimension into all the three different channels, and that crop region will be stored into your B, G, and R variables. Okay. You can also give a specific range. For example, here 100 to 500. That means this is nothing but your pixel location. If you have marker, or you can understand.
So,
Sorry.
the cropping the images there, no? Assume that the image size is 500 cross 500. and we are trying to crop the image. Here we mentioned here 100, 100. So it's going to crop from the top left corner.
From the top, 0, 0.
I want in a random order like bottom.
So you have to use this one, this way.
Okay.
For example, if let's say this is your image, okay, and if you are using the statement 100, 100, you could try to drop from 0, 0, go 100 in width, go 100 in height. So that much information will be captured. But if you are using 100 to 150, it goes to, let's say, 100 in the x direction, from 100 to 500 it checks that width, and then 200 to 700 that height, that middle portion will be captured in the state. This is image resizing. So if you want to resize the image, for example, could be shrinking of an image or an expansion of an image, you can use dot resize method. Now here, shrinking of an image obviously makes sense because, for example, if you have the image of 100, 100 dimension, and if you want to downsample it by 2, you obviously have a choice to pick alternate pixels, right? And then take the downsized dimension of 50 ohm. But then, what if I want to increase the size from 100 to 100 cross 100 to 200 cross 200? Okay, so that means you are creating 1 pixel gap between each alternative pixels there. Now, how do you fill it? There are some operations called interpolation methods. There are various different methods like linear interpolation, bicubic interpolation, and some other spline interpolation methods which you can use. Those as a parameter you can pass it to the function dot resize and then achieve your resizing. Okay. So this fx comma fy is nothing but the destination dimension which you want. Either it will be double or multiple. Next is about the color space. You have multiple color spaces. Could be RGB or HSB, CMYK. So depending on your task, you can convert to any of these color spaces. There are readily available functions in the OpenCV library. But however, said that, you also should understand what is the algorithm running behind this conversion. Like for example, if I convert from RGB to hue saturation value, how are these pixels being combined together to create a hue value, and how are these combined together to create a saturation value and so on. So yeah, you can definitely go back and check all the details of how this conversion works in the background. But however, we will use only the specific methods available. So these are few of the okay. Now, as I told that if you are making a color image, you have the option to split the different channels into its R, G, and B channel. So this is what I have done. CV.split. It splits all the other different channels into VGR. If, for example, the image is available in your CSV format, then you can still split it and store the variables into hue saturation and value, and can display them visually. Okay, we have an exercise for this also in our second session. You can see that. Now, for example, to convert it from one color space to the other, you have BGR to RGB, BGR to gray, BGR to white BGR. So these are the methods by which you can convert from one color space to the other color space. And the method which you use is CVT, that is convert color, CVT dot CVT. Okay. Next is we can also perform some kind of arithmetic operations on the images, just like we do it with numbers, addition, subtraction. Okay. Now, since one thing to be noted in the background is that all the images which you are reading, they are all two-dimensional, so you can treat them as matrices. So when you try to add two different matrices, you always have to keep in mind that the dimension should match. The number of rows and the number of columns in both the images should be same. Okay. So the same logic applies here also. Whenever you are trying to add two different images, make sure that their dimensions are same. Similarly for subtraction and multiplication. Obviously, image multiplication we cannot imagine what operation it is doing. Okay, so maybe just for addition and subtraction, you can imagine that two images are being added together, kind of overlapping on each other. And subtracting means you are taking out some part in the image and then doing the subtraction. So for that, we have the method dot add and dot subtract. You can pass both your information and then there is one more method called dot add weighted. For example, if you are trying to add two different images, uh, how much weightage should be given to each of these images? For example, if I want to give more weightage to image 1, I can specify here weight as 0.8. And similarly, if I want to give less weightage to this image 2, I can say give it a weightage 0.2. Okay. So at the end result, you can see that the image 1 is more dominated when it has been added. Okay, so these are few of the results which you will again see in your second session. For example, that's image 1 and 2. It's like a galaxy image and then there's construction building. When you are trying to combine both of them, add together, this will be the result. You can see, looks like it's an overlap of one image on the other. Subtraction image, this is more like you can see this more visually onto the black and white image. That's why I use this example. One is the star image and the diamond image. When I'm trying to subtract this diamond image from the star image, this is what you get. Okay. So this again kind of we can still expand this to a color image. What happens in color images? It applies the same logic onto all the three different channels. Okay. This is not arithmetic operation, it's logical operation. Sorry for the title. Now, similarly, like arithmetic add and subtract we have used on the images, you can also use the logical operations like AND, OR, and SOR. Again, keep in mind that both the images should be of the same dimension, the source and the destination. Nothing to explain here. Okay, just some sample examples. The first image is white black. Since it's getting merged into the background, please make sure that you have the white portion there. And this is the second image. When you AND together both the inputs, AND is what? This is, let's say, x and y. 0, 0. When you are doing the AND operation of 0, 0, it will always 0, right? Only when there is 1 in both the pixels, you will get 1 output. So you can see that wherever there is a white portion in both the images, only that portion is white, and the rest all is black. That's a simple example of AND. Similarly, OR and SOR. You can try this also. Okay, next is image blurring. Although looks like a stupid idea, why do you have to really blur the image when you are getting a nicer image? Okay, but the idea behind image blurring is to suppress the noise. Now, how does this blurring operation perform? Is, for example, if you have the image here and you have some kind of a high frequency information, something like this boundary. So all of these edges are called your high frequency information. Okay. Now, what happens when you are capturing this information? There will be a lot of noise introduced into your image. Now, how do you remove these noises? So these noises are removed by smoothing all the information into your image. Now, how do you smooth it? You have to actually apply some filter onto each of these pixel locations so that it takes the information from all of its neighboring and then replace the target pixel with that collected information. So there are operations like Gaussian blur and median blur and bilateral filter which helps to reduce the noise level in your image. But the only disadvantage of these blurring is that it reduces the high frequency information in your image. Although you may get away with all of these noise, you may get a smoother image, but the problem is all the high frequency information will be little bit blurred out. So with one hand you are getting something and then the other hand also. We can also see these in our practical sessions. Now these are few of the functions using which you can draw something onto the image. You can draw a line, arrow line, ellipse, rectangle, and also write some text. Put text is a method. Dot put text is a method to write some text on your image. I will not go into details. Whenever you are facing a difficulty with any of these methods, you can directly go to OpenCV.org, type in this function name, and then it gives you the description about something like a man page, where it gives you the details of all the arguments and how to use it. Some usages. Image transformation. About resizing, I've already discussed. Image normalization is another very popular step which is generally used in machine learning. For example, whenever our image, like most of the time we'll be using 8-bit image, but what if the image is a 16-bit image? For example, the center image is a very high resolution image and they need more bits for saving these values. So when I say 16-bit image, that means the minimum and the maximum value could range very far. Their dynamic range will be very far. But then dealing with such a huge number may not be so easy for the computer to process it. So sometimes we happen to normalize it. So normalization, what happens is, if you have a range of 0 to let's say 1000, it converts it to a range 0 to 1. So that is the reason for although we are not manipulating any values or fixed information into the image, it's just that we are limiting our dynamic range between 0 and 1. This is about image transformation. Okay. Now, sometimes it happens that we need to transform the image. Maybe it could be a translational, or it could be rotational, or it could be some amount of a shifting in the image. So you have the methods. For example, wrap affine, dot wrap affine is a method which you can use to transform your image. But then the parameter is what it matters. This image RGB is your input image. So wrap affine is nothing but a function which accepts the input and the transformation matrix and the given the right. Now, this transformation matrix could be anything. Could be a translational matrix or a rotational matrix or a field matrix. Okay. It all depends on what value you feed to this. For example, if the transformation matrix is 1 0 0 0 0 1 0 1 0 0 0 1. Okay. So for example, if this is a combination matrix, whatever input you have, you will get the same output because it's an identity matrix. Okay. But for example, if I add some value to this, for example, ex or ey. Okay. So if you actually do the matrix multiplication, you may find that if this was the image, your image might have shifted x bit and y bit, so that your new image is something. Similarly, you can change the rotational matrix by changing these values. Maybe you can add some value, let's say rx and ry is similarly for shape. So it all depends on what matrix do you pass to this dot wrap affine function to translate your image into the different.
In which situation we use this function?
Sorry.
In which situation?
Situation you can say, for example, he has mentioned about the moving traffic, right? And if your object is not in the center, if you want to bring it to the center, because all the visuals happens in the center of the image, you can translate that image to the center point and then perform it.
Yeah, actually, Sam will cover more topics on that. So, if you bring, I will come back soon. So, a lot. Yeah. So 10 minutes. As soon as you come, you start, you will go. Answers will be really useful for you.
Thank you, sir.
Okay, welcome back to the session, second session. So we'll start. Soon we'll be completing the report and then we'll have the answers. Any doubts you have, you already can discuss with the research person. I need to discuss among yourself in person.
No? Hello?
Yes. No, sir. Sir, the mic should be little close to me.
This much? Oh.
It will come.
Sensitive. Alright. You can't move my head.
So you can wear it here. Ah, bit.
Go like the headphone.
So this, yeah,
Ah, yes.
yes,
Oh. Better? I'm imagining my college days. Alright, so welcome back after a short break. So this is about the image transformation. You can translate it, rotate it, and do a shear transformation to be shifting it as well. Next is the edge detection. Like in initial lecture or on the talk, I was talking about the low level vision, mid level vision, and high level vision, right? So the edges are nothing but your most prominent and high frequency details near you, which is nothing but a low level vision information. So detecting the edges also reduces a lot of details in your image. So there are few methods by which you can find the edges in the image. You might have heard of these terms in your MATLAB programming also. These are concepts, these are methods available here. It's dot candy and dot circle. There are a few other edge techniques also. We can explore them again. But what is the main importance of finding the edge information? It's, for example, if you want to draw a shelloid of any object, for example, the outer boundary of any object. So when you try to apply these carry edge detection or sovereign edge detection, it tries to give you the outer boundary of the object by which you can determine the object size and object shape and then take an informed decision, right? When you are trying to show a picture of a car to a computer, it may not be able to really identify it as a car until unless you, because all of them are just pixel information, right? It could be tree or a car or any person walking on the road. It is all just pixel information for the computer. But until unless it tries to figure out the shelloid of the object, its outer shape or the outer boundary or the contour of the object, it will not be able to determine what object it is. So all these edge detecting algorithms will help us in detecting the edges in the information. Now these are very primitive edge detecting techniques, but however, if you are trying to apply it into a real world scenario, you might face a lot of challenges. For example, like for example, this mountain example, if I say these are the edge information which you want to predict, but because of noises, you could get some other noise edges into your image. So how do you tackle that? So those are all the advanced topics which you can explore as you go along with the project. But these are the basics which you can use. Now here, especially about the scanning edge detection. the pre-processing step for finding out the edge information in the image is that you have to first convert it to your specified color space. It could be either your RGB space or YCDCR space or anything. And then you have to blur out using the Gaussian blurring. Now the reason I explained that why you need the blurring operation is to smooth out the noise in the image. Generally, whenever you are doing the averaging over a certain number of pixels, it always reduces the noise. There is one equation, I'm not really sure about it. But then, for example, if let's say this is the area and this is the target pixel, you want to find the value of this particular pixel using the neighboring pixel. When you try to sum of them together and then average it, let's say this is a 3 cross 3 window, when you average it, let's say by 9. So this average out all the information around this pixel and using the value in that particular target pixel. Now, when you do this over a complete image, you will see that the total amount of noise in the image is reduced. So the reason why is because even the noise information also gets averaged. If let's say the capital N is the noise, the total information in the image will get averaged by capital N. So that's the reason why when you are doing the Gaussian blurring or any of the blurring operation on the image, the noise also gets reduced. Now once the noise reduces, that means you have removed out all the outliers, and then now you are ready to apply your segmentation. So I've just given a little bit of details about candy edge detection. This was developed by John and Kenny, that's why the name candy edge detection, and it is used in applications to detect wide range of edges in the image. It is not just the straight lines like horizontal, vertical, or diagonal edges. It could be any quantum of edges also in the image. Now, how do you do it? There are multiple steps in this. First is noise reduction. So, any given input image, you have to first reduce the noise by either applying the filtering techniques or blurring techniques. Now, once you have done that, you have removed out all the noise. Now, you are ready to calculate the Gaussian information. Now, what is Gaussian information? For example, if you have this image and if you want to find out, let's say, the horizontal information or the vertical information in the image. Now you have to find out how is this gradient across this horizontal. That means when you are coming from here to here in this direction, you see that there is a gradient information change. For example, this is a white pixel and this is a black pixel. You see that at this particular location there will be something like this. Okay? There is a gradient information at this edge. Similarly, when you are trying to find the vertical edges, there will be a gradient change at this particular pixel location. For example, like this. Okay. So you have to find out the horizontal and the vertical gradient and then combine them together to find its actual gradient value and the direction. So the direction could be anything. It could be even in the diagonal format also. So once you find the gradient information from the image, you will get a lot of sets of edges. Now, not all of these edges could be essentially required for your final decision making. So, what you have to do is, next step is non-maximum suppression. This is another technique by which you can get rid of the edges which are not really important in any of the further processing. For example, if this is the image and if these are the major edges which I've got, along with this, if I have lots of edges which are really not connected to the main edges in your image, we can definitely get away with all of these minor or outlier edges. Okay, that is what is non-maximal suppression. And the last is hysteresis threshold. In this, what we do is we will set two thresholds. Let's say one is 200 between the range of 0 to 1000. Let's say 200 and let's say 800. If a pixel information, if the edge gradient information is greater than 800, that is confirmed that that edge is more prominent and that is required. Okay, so we'll keep all the edges whose gradient information is greater than 800, and the gradient which is below 200, that means they are all weak edges. We will not retain them. Instead, we will discard them. Okay, and whichever is the edges with radius between these ranges, we would try to see if those edges are really connected to the major, the main dominant edges or not. If they are connected, we will retain them. If they are not connected, we will discard them. Now, all of this you are not doing it upfront into the code. All of this is taken care in the background of the catenation section. Okay. Now, just by using the dot tagging, it will all take care of this internally. And these two values, max, min, and the min value of the max value, which represents the threshold for the gradient. Next is morphological operation. So, okay, so there is this operation which is available in CV library, OpenCV library, which helps you erode or dilate the image by using some kind of a structural element. What do you mean by this is, it is again kind of the way by which you can cut short the edges or you can dilate the edges by certain pixel values. For example, if let's say I have this image, okay. Now, if I erode this image, what happens is, for example, there are certain small bubbles which have come out, which have been appearing at the circumference of this circle. Now, if I want to get away with all of these, I would first do the erosion. That means it minimizes the area of this. Okay. Now, by which you can get away with all of these small little outliners, and to bring back the original, to bring it back to the original size, I would do the dilation. Okay. So these are the two different methods by which you can get away with the non-disconnected components into your image. So erosion and dilation. So erosion means it clips or removes or erodes the surface. Dilation means it dissolves. That means it expands a little bit of the size of the overall object. Now, it all depends on what kind of structural element you are using for these operations. These structural elements are nothing but your filters or the kernels which you call. It could be either in the size of 3 cross 3, 5 cross 5, or 7 cross 7. Okay. And it can also vary in sizes. It could be in any form like square, circle, oval, or any other shape. So whichever structural element you use, it just hover over your complete image and do the convolution and then try to do the erosion and diversion as per the. So this is what I have explained. It removes the noise and attaches any two connected objects. The opposite of erosion is dilation. If the two objects are disconnected by a certain fine line, but they are actually connected together, you can use dilation. And there are few operations called opening and closing. These are nothing but the succession of these two different operations. Opening is nothing but erosion followed by dilation, and closing is nothing but dilation followed by erosion.
So, what do you mean by white noise and
Sorry?
white noise and
White noise is nothing but your whenever you are trying to capture the image, all the environmental noise is what we call as white noise. So they are all additive noise. Multiplicative noise is your salt and pepper noise. That means, for example, if this is your image, the pixel information has actually changed the value to either 0 or 255. That is the salt and pepper noise. Salt is like white and pepper is black, something like that. So they are all multiplicative noises. And this white noise is nothing but additive noises. For example, if the pixel value here is 10, some noise gets added, for example, 20. So this will be the new pixel value. So this is called as additive noise.
How to remove additive noise?
Sorry?
How to remove additive sound?
Additive noise you can use it using your Gaussian blurring or any other filtering techniques. Blurring is there, right? I've just mentioned Gaussian blurring. So when you do a Gaussian blurring of the image, all the additive noise gets blurred out.
What about salt?
Salt and pepper noise, you have to use the median filter. For example, if let's say this is the region of interest and you have certain black pixels in your region, let's say this is 7 cross 7. If I take the median of this, for example, median is what? you first arrange the sequence into the ascending order and then find the middle of it. Okay. So since these black dots are very less, so obviously they will fall somewhere in this region, and rest of the information, the correct information is this in this region. So the median of this will be somewhere in the middle, right? So this information, this pixel value, we will fill it into this box. So that's how you get a bit small filters. You have to. So yeah, these are the two different noises which are.
Sir, you said started multiplication.
Multiplicative noise.
How we are saying on what basis you are saying this first?
Multiplying means like it just multiplies. If a pixel is turning black, that means it gets getting multiplied by 0. So it's totally making it 0. Similarly, if it's getting multiplied by 1, so whatever is the pixel value, it gets converted to the saturation 255. But additive noise is not like that. It just adds a certain constant value to each pixel's image. Okay, so these are few examples which we'll again explore in our second session. Dot dilate, dot erode, and dot morphological examples. Yeah, so kernel is nothing but your structural element or the kernel or filter, whatever you name it. You have to first define it. The way I have defined it is nothing but a unity kind of a pixel, which is 3 cross 3 with all ones. Okay, but you can choose your kernel size and then apply it onto your image to interact it. Next is histogram. I think most of you are also aware about this operation. Now, histogram is nothing but way by which you can find out how frequently a pixel value is appearing into your image. Okay? So this is nothing but a graphical representation of the pixel value versus its frequency. For example, this is pixel value, and this is the frequency. Now, if I am talking about an 8-bit image, my minimum pixel value will be 0 and the maximum pixel value will be 255, right? Now, this dot calc list automatically finds out into this image, let's say it's of size 512 cross 512, total number of pixels. So, at how many places or how many times the 0 pixel was there. So, it just finds the frequency of it. Similarly, pixel value 1, how many times it has occurred in the image. Something like this. So by this you can find out some structure in the image to figure out whether the image is more towards the darker side or brighter side. Just by looking at the model of this graph, you can figure out whether the image is more darker or lighter. You can also apply some kind of histogram equalization. What it means is, for example, if your image is more darker, your histogram will be aligned to one side of the graph. For example, if this is your image and this is your pixel value and this is your value, frequency. Okay. Now, if your histogram is something like this, okay, which means that the more the number of pixels in this are appearing towards the darker side. Okay. Now, what histogram equalization does is try to smooth out the image, not smooth out, it tries to equalize the image brightness such that this model will still be maintained. There will not be any informational structural changes in the image, but the histogram will be equalized between the darker and the brighter side. So it may little bit spread your image something like this, and when you try to print this out or display this out, you will see that the image has become more brighter. Okay. So dot equalize is the operation is the method which is available to equalize the okay. Maybe this video part we can skip, but however I can show you the advanced CV applications. Now all of these operations which you have seen till now, there are basic operations involved in any image processing or image manipulation. But what is the ultimate goal? Ultimate goal is to extract this information and further make some decisions, right? So image segmentation is one such approach or an application application in OpenCV by which you can segment out the foreground region with the background region. So here, okay, this is all information which I have mentioned. So image segmentation is one of the key computer vision tasks. Partitioning the images into its multiple segments. For example, if you have multiple objects onto the scene, there is a tree, road, car, buildings, and pedestrian walking. If you want to segment each of these objects onto the from the image, you can use the segmentation to figure out which is the foreground and which is the background. There are again several different levels of segmentation. Semantic segmentation, instant segmentation. I mean, it's all not required, but however, basic segmentation is just to segment the foreground object with the background object. And it is mainly used in applications like self-driving cars, medical image analysis, satellite images, and object detection and tracking and so on. So this is one of the simple segmentation technique called dot threshold. Now what it does is, so dot threshold is nothing but it fixes up one threshold value, a constant threshold value. Whichever pixel values are above threshold value, it treats it as one object, and whichever threshold value is below the threshold value, it treats it as another object. So thereby, we can segregate these two objects differently. Okay. Now, here the important thing is how do you find this threshold value? Now, this dot threshold is the method which is available wherein you have to give the threshold value which you figure out manually or heuristically. Just by looking at the image or just by looking at the histogram, you have to figure out what should be the threshold value. But then that will not be possible all the time. You will go wrong also. A pixel here and there also might matter because the regions should be clearly, the foreground object should be clearly distinguished from the background object. So there are some methods which I will show you briefly, wherein you don't really calculate the histogram, the threshold value, but instead the algorithm will compute for you. Okay, so this is very primitive threshold method. You just provide the threshold value, and threshold techniques like threshold binary, threshold count, and threshold to zero. So this is threshold to zero. What it means is if any pixel value is less than threshold, you make them all zeros, and every other pixel value you make it as 255, thereby clearly distinguishing which is foreground and which is front. Next is adaptive segmentation. Now this is another technique by which you are not really fixing a constant threshold value for whole of the image. You are trying to figure out a small region, and for each of these regions you are trying to figure out the threshold value. Okay?
So more than one threshold we can.
There will be more than one threshold value based on what region you have chosen. Okay, this is called the adaptive threshold. Because sometimes what happens is if you are taking a picture from one side of the location in the environment, because of lighting conditions, one scene could be more brighter and the other scene could be darker. But that does not mean that the lighter portion is the foreground and the darker portion is the background. Maybe all of these objects which are appearing in the image, they are all foreground, the rest is all background. But only because of lighting condition you cannot decide. So what you will be doing, you have the multiple threshold values based on what region you have chosen for the image. So for this, there is a method called dot adaptive underscore threshold underscore minus c. Okay, what is this c? This is basically how to arrive at this threshold is, okay, there are different methods again. There is adaptive threshold, mean minus c, and Gaussian minus c. What happens is you choose some window, you find the mean value of all the pixels in that window minus some constant value which you have decided. Okay. Like for example, by manual inspection, you might have decided okay, the threshold should be around 120 pixel value, so that constant value should be minus or subtracted from the mean value. That will give you the exact.
Minus c or underscore c.
Yeah, as an argument it is underscore c, but the actual operation it is doing is the average minus c. that needs to be there is one more method called Otsu thresholding, where you don't really have to calculate anything, it does it by itself and gives you the proper threshold value. For example, here in this case, I've shown a histogram wherein this is the pixel value information, the frequency of the darker pixel and the lighter pixel. But by manual inspection, you could see that the threshold value should be somewhere in between this, but you might not know the exact value of it, right? So this Otsu method will try to find out. Uh, it should try to maximize the inter-class difference and minimize the intra-class difference. Okay, so these are the two terms which it uses, and so this graph you see, right, this is nothing but your threshold value estimation as the region progresses. Like as the pixel value progresses, you see that the threshold value is somewhere here. When the complete image is processed, you will see that the peak of this curve will actually be very. So yeah, so this is the Otsu thresholding. Image denoising, the basic primitive denoising method I have already told that you can either use your Gaussian blurring or bilateral filtering or if it's a multiplicative noise you can use what did I say? For multiplicative noise you can use median filtering. Okay, but they are all standard filtering to remove your additive and multiplicative noise. But there are some high-level approaches also to denoise an image. One such algorithm is called non-local means. Now, all these operations of primitive blurring or primitive denoising techniques, if you have seen, they are all local means. For example, in this image, you only choose a certain window, and this is the target pixel. You look at the surrounding pixels and try to find the mean or try to find the Gaussian, average them together, and then fix the value for the target pixel. This is called as a local mean. Okay, but there is a popular algorithm called non-local means denoising, by which you don't really look at the pixels surrounding to this target region, but instead at all the other pixels in the surrounding. Okay. So this is non-local means denoising. The method which is available is dot fast NL means denoising color. Okay. We can come across this values. For example, it takes P1 and P2 are 2 points in the image. For example, if let's say this is the point which you want to denoise, it looks for the P2 point. Now this P2 point has to be all the other pixels in the rest of the image. Okay. And P3 and P4 are two of the threshold points. For example, if your pixel value is very much below the threshold, it makes it as 0 or it's 255. And yeah, similarly, P5 and P6, I think, yeah, they are also some kind of a threshold. You can look into the manual and see what are these values. So, what I mean is there is this derivate function library method which is available for us to directly use the non-local means. You can clearly see this input and the output how nicely it has reduced the noise. But however, the penalty is all the high frequency information will also get blurred out, but not so much. Image inpainting. This is another one such algorithm by which you can restore your previously scrambled or distorted images into a final image. For example, if the image has been marked by some black and white markers which has gone bad, so there is a technique by which you can restore that image. There are two popular algorithms by Kelly and Navier, that is called underscore Kelly and underscore NS. So these are again popular methods for inpainting. What it does is it first tries to find out the mask which needs to be removed. For example, you can go to the next slide. So is one image which is marked by some marker. Now we first need to, what splitting means is, without tampering any of the original information, how do you actually fill out these marked locations? Now first step would be to find out where is mark present, and once you find out this mask, you have to fill out these masks by looking around the surrounding information. For example, if I want to fill this particular black mask, I should look around its surrounding and see what is the average value of this region of interest, and then fill accordingly. Now this Kelly and India Xavier's method, they differ because one actually tries to look for the gradient information vertically and horizontally. The other one tries to look for the information along the edges. So these two methods we can try out and see how the output is.
So
This is,
how did we get this middle image?
sorry,
Middle.
this one. Okay. You can think of it as, now since this is a black color mark, you can assume that wherever in the whole image, wherever you see the black mark, you retain that, or in this case you can convert that to white, and wherever you have the non-black mark, you can mark it as black.
But
even in the cat also some black mark.
Yeah, but they will not be pure black. Even if it's black, when you are trying to fill the information by looking around its surroundings, it will still be indicated as black. You got the logic?
And if we have a blanket,
Sorry, that's what I'm telling. If you have the black information, for example, if let's say this is the cat and you have the black mark here, okay? Now since the surrounding here is white, this black mark pixel would look at its surrounding and try to average out its fill it with white mark. For example, if the object itself has a black mark, okay? So for example, in this case, if you have something like this here, black region, now it looks around the surrounding and see, okay, this is already black, so this could be a part of object itself.
edge we have to take this.
Sorry?
Edge we have to consider. We consider the edge, then we'll take its.
Yeah, it starts from the object edge and then progresses inside the object. If at all, this is the point which you are trying to indicate.
Why you are taking that point? So you take edge.
This edge.
No, on the cat itself, it has patterns, no black and
Huh.
okay.
So it may not be a pure black also. For example,
If we have a black.
Pure.
yeah, if you have a pure black, then it would try to see, okay, you mean this particular point, right?
Yes.
Yes. Yeah. So if this is a point, then it tries to see, okay, this particular information, it has white here and black here, it tries to average this information.
Here it will take average.
Yes.
In that case, it is taking surrounding.
Yes. So these two different techniques are there, delta and. However, your question is valid. For example, if let's say, if I have purposefully marked a black line on this, okay, then that can be removed. But if the black part is the part of the object itself, that much information will be lost. Little bit information will be lost. But however, the original picture, wherever you have the painting done, that can be restored. Okay, I think maybe with this last topic we can stop. So this is the image registration. Now what happens is, for example, you have taken multiple images and then you want to see, okay, which point in one image corresponds to the other point in another image. Okay. For example, if I have taken the picture of this classroom from this point and from that point, now how do I know this blue mark glass is the same from this position as well as from that position also. Since the viewpoints are different, I need to somehow convert one of the image such that the information in first image is taken as a reference and we can easily find out the same object in the other image also. Okay. So this image registration helps in aligning all the different all the images which are taken from a different viewpoint with respect to one of the reference images. For example, if you are taking a pixel, if you are taking a picture from this position, let's say this is your image one. Okay. Now you have come to this position. You are taking the picture. Okay. Let's say this is image two. Now in this, let's say the image is appearing something like this, and when you are taking the picture from this position, the camera is facing this side. Let's say it gives you the picture like this. Okay. Now how do you know? Now since the information in both the images are same, right? The information of the same object. So somehow we should find the similarity between these two images by finding the mapping between these three corner points. This is just an example. Okay. These are called as key points in the images. So once you get the mapping between these key points, we can definitely say that this point corresponds to this point corresponds to this, and this point corresponds to this. Okay. Now there is one concept of homography by which this is again a 3 cross 3 dimension. So homography matrix. Once you find out this homography matrix, you can homography is nothing but a matrix which tries to transform your input image to the reference image. Okay. Now once you get this homography matrix between two images, you can convert this I2 into a format or into a shape such that this particular key point is directly into the horizontal line each of the reference. Okay. This is the image registration technique which we have. So it helps align all the different images of the same scene taken from a different viewpoint. And these are few of the operations which are mentioned that first you have to match the features in the image with respect to the reference image. Then you have to figure out the key points. Key points are nothing but the prominent corners and the edges to the information. Then you have to extract the descriptor, which is nothing but a histogram. And then you have to match the key points between the image 1 and image 2. Once you have the matching between all of these points, that means you can easily get the transform matrix, nothing but your homography matrix. To calculate this homography matrix, you need a minimum of 9 points between image 1 and image 2. Once you get the homography matrix, you apply this H matrix onto I2 to align it into the I1. Okay, so that each key point in I1 will be straightway available into this straight line from I1 point. Okay. So once you have aligned it, you can easily figure out okay these two objects are same, and this image registration also helps you in stitching your images. For example, if these two are two different images taken from two different viewpoints and you want to stitch them together. For example, this has some information here, or this I2 has some information, extra information here, and you want to stitch these two images. So this at this point will be so this at this point will be stitched here and stitched here, and this extra information will be put in here. So your image will be little bigger. I think panorama concept is similar thing. You try to stitch the two different images based on its key pointers. Okay. So we will also see this working example in our class. You ideally need two images, convert them to grayscale, then define the detector, define the matcher. So all of this has become very easy for us to do it in OpenCV because it provides us with a lot of methods. And then create two matching points, then P1 and P2 get it, and then create you find the homography between those two pairs, P1 and P2. Once you find the homography matrix, you try to warp it or transform the I2 image with respect to the homography matrix so that all the key points in I1 and I2 matches. Okay. So yeah, I think maybe we can stop here. If you have any further questions, we can discuss. I had this video processing also, but this is again, if time permits, we can have it in our lab session. But this is just an extension of images. Like instead of processing each individual image, we process it over the video. So in video processing also I was about to show, maybe quickly I can slide through. How do you capture the video and how do you process it? That is again your image processing techniques, and how do you write it back after processing. So video capture function is there and video write function. If you have any questions, you can discuss.
Start with open collab. Second, open the collab notebook. So whatever the notebook you have used in the last session, you can continue with that. Okay, so whatever service, then you can continue with the same things so that we'll have the entire document. Even if you not open the Google Colab, so whatever SQL you have had in the Colab, you can continue with the same. So open so especially, so like from installing OpenCV, I believe that typically we can install in OpenCV. It's not, it will just take a minute to install it.
Are you all from CS department? All faculty? Sir, you are from mechanical. EC. How many of you have experience working on OpenCV?
But sir, this OpenCV is bit old it is nowadays. Why? Because nowadays what we
For research purpose, you can definitely use it for your day-to-day activity of teaching.
we are working on convolutional neural and all, extracting the features.
Yeah, obviously you can import the packages, whatever keras or whichever tool you are using. You can use it. Importing is just importing packages only.
Decision making can be done by deep learning. And feature extraction is done by using OpenCV. Am I right, sir?
Yes.
What sir?
When we are talking about these feature extractions, we can.
And decision making.
Yeah, we do sir, the feature extraction can be done using OpenCV.
Yeah. OpenCV has these tools for image processing, but if you are trying to work on the advanced deep learning techniques, for example, like you said, feature extraction and segmentation and other classification techniques, there are these TensorFlow and keras and Caffe. There are so many other libraries which are available. You install them and bring it to your OpenCV. Just say imported those packages. So once you import those packages, all the functionalities or methods available in those libraries will be accessible in your OpenCV.
I believe everyone have opened.
Yes. So all of you are familiar with Google Colab. So there is a wonderful feature in Google Colab which is AI generated code. How many of you have used it?
What's that?
AI generated code in Google Colab, there is a feature. Have you all used it or no? Okay. How many of you have used ChatGPT?
By default.
उठे तो बैठे तो
So it's just an extension of ChatGPT. Google Colab is by Google. So in the background there is Gemini 2.0 which is running and tries to interpret what you are trying to ask. Based on that, it tries to suggest you something. Okay. So there are features in Google Colab by which you can directly ask the GUI wherever it is. There is a text prompt which is available. You can ask it to generate the code for you, or during the execution, if you face any error, there is a provision that you can also try to ask for what is the cause of those errors, and you can also ask to rectify it. So almost OpenCV is doing half the job for us. Generative AI is doing other half job for us. Okay, so it's very convenient and easy for us. I'll connect to Google Colab now. And,
From Google Colab Matches. वो try करने पर भी वही problem है.
कौन से डिपार्टमेंट का सीएस गुड नेम है नियर द प्रोडक्ट
Where you are working, sir? For example, Manali.
So maybe you can start by creating a new Python notebook file.
There's some issue with I am show and Colab.
Yes, yes. I'll come to that. Okay, so since Google Colab is already a pre-built, it has a pre-built image with a lot of libraries and packages installed into its background. So how this Google Colab runs is there will be a image which is in the Docker, and it tries to fetch that image and run it on your local device. So in case if you want to see what packages are available, you can definitely list out them. But then, if you want to specifically, since we are using OpenCV Python, you can just try and execute this command if it's not there. Okay. So, okay. Second, so this exclamation mark tip show OpenCV Python. This is the tip install it is actually, but then obviously you don't need this because this image of Google Colab would already have this package installed in its Docker. But still you can use this, and once this is done, you can check if the OpenCV Python has installed on the system or not. You can just import OpenCV as CV, OpenCV as CV. Now export wherever we want to use or call the methods inside the methods available inside the CV library. You only have to use CV dot method. You can try to print this version and see if you are able to get the version number. For me, it is working. It is installed. It says 4.12. Right. Okay. So all of you are with me.
Yes, sir.
Anyone not getting this? Not getting?
Got it, sir.
Anyone who's not getting?
Show OpenCV.
Okay. I assume all of you have got this. That means CV2 is installed on your system. Now you can use all the methods available inside this library. Let's go ahead and okay. So these are few of the sample images like cameraman and Lena. Uh,
Dumb in the drive.
yeah, I was using the runtime folder here. That's why it is slash content. But if you have any other files on your system, you can use that. How do I share these to Sriram sir?
We'll download them.
These are files to be shared.
Or any images we can use.
Ballari district, sir. Ballari district. Yes. Who is reporting? Four years. Lena, sir, Lena. Lena, L-E-N. His favorite image processing what is that? It's Google image. Mail number. You details में सबमिट करना तो दे दो ना कोई किसी को इस तरह you wife 4 members mental issue sir Monday admit हो गए hospital ये simple sign but they you should have like you can go for no cash or else cash reimbursement मैं 2 बार रिप्लेस किया नहीं सर वो
Rather be sharing here, which set of things that we will be working on. I'll send it to your mail ID as well as investigate. The mail will be better.
PDF చేసేసి సిస్టమ్
చూడాలా అలా దివసాలు వచ్చిగా నేను ఓపెన్ చేసాను నేను కంటిన్యూ ప్రతి కట్టందిరేమో కదా अब नया नहीं मेरा बच्चा है नहीं
For time being, until we share the images, if you see any images on your desktop, you can just pull that into your collab, and then maybe we can execute these IM read, IM show, and then IM write function. For IM show, it is there is deprecation of that particular function in OpenCV. So there is an alternative function called CP to underscore IM show. I'll show that. I'll just show it. You can use that.
Well, last week it was that's the cross. What the
major changes.
अरे वो न्यूज़ ऑटोमेटिक गूगल में लगा mock test எடுக்கிறதாக்கு ஃபர்ஸ்ட் ரவுண்ட் பொசிஷன் ஈக்குவல் They are throwing.
I have said that also. What is
Okay, the data set has been sent to your mail. Sorry for small delay. You can download to your mail I have sent. You can download those data files. The data set has been sent to your mail.
Okay, so here what I'm doing is I'm taking these two images. One is cameraman.pif and Lena color, and I'm just dropping it. Yeah, so I'm dropping it in my local runtime folder. There are multiple ways by which you can access this. Either you can save it in your drive, Google Drive. From there you can access it. But for that you need to have the Google Drive mapping into the Google Colab. Okay. So for now I have these two images. If I want to see path, copy path. Let me just enter here just to show you what the path is. So you see, this shows slash content slash camera. Okay. So slash content is a temporary folder until this GUI runs. The session is active. Okay. Once the session is terminated, all the content stored in the slash content will come. So for now, we have these two images. I use cv.imv command and keep the path as string. Okay. Store it into some destination variable. So this is the first statement. I'll keep going. If at all any of you are not following the pace, if you can raise your hand, we can slow down. Okay. All right. That was about IMV. Now you have to display this image, right? For displaying the image, IMShow is deprecated in Google Colab. So we have the alternate function called CV2 underscore IMShow. You can call this method available in this. You can say class or a Python. Generally, you are aware about this way by which you call the functions, right? This is like a main library. Dot collapse may be another class in it, and then this will be like a function in it, and this will be another method in it. So ultimately, we need this method. So from this import cv2 underscore im. So in all of the statements below this, we will always use cv2 underscore im show. Okay. Now, once the first statement of imv is complete, you use cv2 im show. In brackets, provide the variable name. Since I have read two different images, cameraman and Lena, I will run it. You can press Shift Enter to run the box. Okay, so you see these two images. One is cameraman, displaying cameraman, and displaying Lena. All of you are done? Yeah. Then third is, although we are not processing any of these images, but however we want to write this image back into the local desktop or local drives with, let's say, some extra string attached to the file. So let's say cameraman img is the variable which is of data type CV mat, CV matrix that you want to write it to a location into your content with the file name press. Okay, so these are two arguments which it takes. One is the file name, the second one is the variable. How do you call IFRite? CV.IFRite. Okay.
Sir, how did you display it? Can you just
How to display?
Yeah, just one.
Yeah. So just
Okay.
CV2.if show in bracket provide the variable name.
So what is the library? Sir? Google.
What's the library? Okay, Google collab.patches. So you are done with three major steps: reading the image, displaying the image, and writing it back into the drive. Done?
Sir, what? I am right,
I am right. Yeah, cv.I am right.
comma,
Give the file name, any suitable file name, comma, the variable. Which variable you want to store? Okay. Now when I run this code block, you see on the left hand side.
Can you go to
Go up.
I'm able to read the English, sir. I want to display.
Yeah. This is the import statement which you have to write to import the INFO method, and then cv underscore INFO address or yeah. Okay. Right. So when I execute this block of code, you see on the left hand side it has created this cameraman image write.tif file. That means whatever information was available in the variable cameraman underscore img, it has now been saved into your hard drive. Similarly for Lena image write.pm. Okay. Done?
there is an error for I am right.
There is an error for
I am right.
you. What's the error? CV. Have you put CV dot?
Yes, sir.
Okay, I will show you also the step where it shows the error. I have miswritten this function and I try to execute this. You see here now I have
Could not find
I
the
have
right.
got the error right here. It says module CV2 has no attribute I and WRI.
Okay, that extension we should give, sir. Dot .tif.
Yeah, file name dot extension.
Dot.
.tif or png anything. Now if you click on this explain error,
Yeah. The first argument in I am right, we are giving the name of the file
yes,
with the extension of.
with the extension.
Got it, got it.
Now see the error. This is a feature of Google Colab. It tries to locate the error and ask the Gemini LLM. Gemini and all these ChatGPT language models, they have already learned from a huge corpus, right? So they already know a knowledge of around 3,000 human brains. So when you try to show this error to the LLM model, it tries to find out the answer by searching in its database and says there is no function named INWrite, and it seems there is a typo. The correct function name is INWrite. So this is one of the response which we got. So by which you can now there are three more options. You either accept this, that means it is automatically correcting your code. or you cancel it. Whatever suggestion it is giving, you can reject it or accept and run. That means run that complete block. So I do accept and run. You see that the previous written command is modified now. I am right, and successfully it prints the message that it has been written into the SSL. Are you following me? Okay. Alright. Next is we are trying to read the image in the color format. Now earlier, whatever information was there by default, this argument will be 1. That means it will be in the color format. But if in case if you want to modify at the time of reading itself, you can provide these arguments like IMP grayscale. So what I am doing here is you can write this statement here. You can read the Lena color image, but provide the second argument such that it implicitly converts it into the grayscale and stores it into the variable.
One. That is different variable, no? Lena color.
This is a different variable, yes.
Okay, one.
This is a different variable. Okay. Now one more functionality which I was talking about. I'll show it here. Okay, so by default, this Google Colab is activated with your AI generative code. If I try to write a comment, let's say, read the Lena image and convert it to YCCR color space. Okay, this is the comment which I have written, and if I hit enter, wait for a few seconds. You see there is this automatic line, or you can say the auto-generated code which Colab shows you. It uses CVT convert color, which I have already explained in slide. This is the input image, and this is the argument to convert it to the image. You can give tab to complete the code generation. Okay.
One.
So it really takes away the burden of a programmer, yeah, and does the processing faster. Although we are not doing this color conversion now, you can for now you can skip it. But just in case if you want to even write this particular statement, the line number 3, you can just write a comment saying read the Lena color image, convert it to grayscale. It automatically shows you this. Okay, alright, we will not go much in detail. Once you have read this, I will execute this block. Now see this, first one is the display color image, second is displaying the grayscale image. Alright. You can also play around with this argument. Color means 1, grayscale, there is the alternative alias integer value to this, that is 0. I execute this line and you still see the output. Okay, first one is the color image. So this one is always by default here. Okay, going to the next, there are a few operations by which you can find the shape of the image or a matrix. So this is the variable dot shape. Dot shape is a method that gives you the dimensions or the size of the variable. If it is a 2D image, let's see, you can write this print statement. You see, cameraman is basically a 3D image, not 3D, yeah, 3D image also you can call because it has 3 channels. The first one is nothing but the number of rows, number of columns, and 3 is number of channels. Similarly, Lena color is 3-channel image, but the last one is grayscale, so you see only number of rows and columns. There is only 1 channel. Clear?
One.
Error at what station?
Before this.
Before this.
Yeah, not this.
Okay. Have you used CV? These are all capitals.
Yes.
IFD underscore color and grace. If you are getting error, please look down and click on explore error.
Name
Explain
camera
error.
is not different.
Is it Google color?
Sorry?
Okay, asking for patch.
No. The patch is only for the CV IMShow command. IMD and IM write are the part of CV library itself.
So here, cameraman underscore IMG, that is your original image, our original image, right?
Original image.
But the dot extension here we are giving as a shape for to get the shape of that particular image. But the extension here is PIL.
No. This is the variable which we have created. It is not the image name. It's not a string.
Variable which we created
Variable we have
when
created here.
when
we read this first time, right?
when we read.
So the first time here, this one.
Yeah.
This is the variable.
Not the file name.
No.
Yes.
Dot shape is a method. It's not an extension. Dot shape is the method.
Yes. One second. It gives the dimension
Yes.
of the image with the three channels.
Yes.
Height, width, okay, done.
Clear?
Yeah. Next we have channels. Blue.
Okay. Now when I say three different channels, although they are 2D themselves, but they concatenate together and form a 3D. For example, this is very basic. I'm not sure if I had to tell you this or not. For example, this is a color image with R channel, G channel, and B channel. But if you take the individual channel as it is, they will have numbers, let's say pixel values 10, 25, 100, 150, and so on. If you take these individual channels as it is, they are still the grayscale image, right? Because they have these pixel values for the blue filter itself. Similarly, green channel and red channel. But how do you actually see if this complete picture only the blue channel? How do you do it? You can either zero out all the red values, green values, and keep only the blue values, and then concatenate all these three channels so that you can only see the blue information. Okay, I'll just show you quickly. Since this Lena is a color image which has three channels, you can use this format colon. That means everything, all rows. Next colon is all columns, and third parameter 0 means 0th channel. Okay. Now, as I said, this is not in the form of RGB. The OpenCV always reads it in the reverse way. The B channel is always indexed 0, green is indexed 1, and red is indexed 2. Okay. So when you are accessing only the 0th channel, that is nothing but your blue channel, green channel, and red channel. Okay. Now, since I have told these individual channels are nothing but your 2D themselves, you can see that they all the three channels are displayed here: blue channel, green channel, and red channel. They look like 2D only, right? A grayscale image. But the only difference is when you try to combine them together and concatenate it, you will get a real picture of a color image. Okay.
Black now number.
That's how you segregate the channels.
less than a percent. That should be.
Okay, so this is where I am trying to create or show you only the blue pixels in the image. What I do is I create a duplicate variable. Okay, what is NP? NP is a NumPy package again. You have to import it as import NumPy as NP. It's a you can say a matrix package by which you can manipulate the matrices. Zeros like is a method inside the NumPy package to create a matrix of all zero values of the dimension given into this practice. Okay. Now, Lena color image is ideally a 3-channel image. So when I do this, it creates these 3 channels and fills up everything with 0. Okay. This is how the first statement is executing.
So 1 second.
Alright.
1 second.
Now we have already extracted the blue channel above, right? What I am doing is I am storing this blue channel into all rows, all columns, first channel. That means in this particular matrix only, I am filling the blue channel values. Okay. Now the red and green are still the 0 because of the first line. Now when I try to print this complete blue image, how does it look like?
Full blue.
Let's see. Yeah. This is still a color image because it has 3 channels: blue, green, and red. Blue channel has the value of blue pixels, but green and red are 0. That's how the blue pixel values are prominently seen. I will execute this and show you now. You see this? This is only blue colors in the image, only green colors and only red colors.
Little up.
Yeah. So only when you combine all of these three together it gives you a color. Can we proceed?
1 second.
Again, I am telling you, you can use your generative AI feature. I will completely delete this code and let me say, yeah, see, it automatically gave the code. So you really don't have to type it everything. Just provide the comments. With a proper prompt engineering, you can achieve your result.
After the comment, we have to wait for 1 or 2 comments.
Yeah, a second or two. That's all.
Then first tab.
Done? Okay. Next is copying an image. Just to create a duplicate image, you are again using a NumPy package np.copy. This is the source image and this is the destination image. Okay. This is just an operation, just in case if you want to save your image as a backup and perform some operation on the images, we can do this copy. Alright, to create a black image totally, you can use np zeros. Okay, np dot zeros. Provide the dimension 256, 256. Also provide the data type, which is nothing but uint 8 in this case. Okay. Now what output you get is a box of 256 cross 256 dimension with all 0 values. Similarly, you can create a image of all ones, that is np dot ones. Keep the dimension flat. That's all. Yeah, so it is already written here. You can see black on the left hand side, black image and white image. Okay. You can go ahead. Okay, next is cropping. This cameraman copy we have already created. Okay, just in case if you can already reuse the code. See how I'm doing. Maybe I can directly write the comment here. Read the cameraman image. It says it. Okay. Convert to, okay, it has already converted to grayscale. So this is the copy. Clear? Now x, y is the starting point, width and height is the cropping dimension, which I am passing into the cameraman copy variable. Now how it works is, this is basically a range. For example, if this is a complete image, x is somewhere here, okay? Now x plus, okay, but that's a 0 to 100. This is 0 comma 0, this is 100 comma 100. Okay? Now if you want to have a crop region somewhere here, what should be the dimension here? This should be, let's say, 25 comma 25, and the width is 50 and the height is 50. Okay. So how do I do this? How do I crop it? I give, this is the x value, this is the y value, this is width, and this is height. Okay. So you can pass these arguments and use the range format to specify the range. Here you can play around with these values just to see how it is cropping. You should be careful that you should not go beyond the range. If the image itself is 100 cross 100 size, you really cannot crop it for this much height and this much width, right? So please make sure that you are always cross-checking these values. Now before I use this plus W and plus H, as I told you, your code should be robust enough that it should always handle the exception. You should always make sure that when you are adding such values, you should not exceed your height or the width of the image. So those exception handling you can do in your code. Okay, so when I run this, you see this is the cameraman image, and a crop of 200 cross 200 is shown here. Okay. Can we move ahead?
Yes.
Okay, these are some basic operations. So cropping we have already seen. This is nothing but cropping of the image by providing certain range. Now these are all just random range values, height and width. Okay, maybe another 10 minutes I can quickly go over this.
Last 5 minutes. We'll explain the concepts of it. The entire time will start with me.
Yeah,
I'll be line by line, you will take time.
Yeah.
We'll explain the concept in 5 minutes.
since the time is limited, I can just scroll through this.
Sure.
5 minutes will explain, go through our entire thing, then I'll be starting this.
It is difficult for us
Yes.
to type everything.
Yeah.
Instead, that file would have been shared with us. Click on run.
After I got the material already, I will be posting it. So after we will copy this soon you can do it.
Yes, sir.
Sir, do you have? Yeah.
Python, after we are going to have deep learning framework in Python.
Deep learning.
Frameworks. I use the OpenCV nursery will also show normal Python. Directly.
No, sir, sessions. Do you have any examples of deep learning model using OpenCV?
No. It's only basic operations.
It's happening in our session. After
Okay.
Yeah. So one of the basic operations which I mentioned is resizing, right? So here resizing means what? Either you can squash it, you can reduce the size or expand the size. So this is the input image. If I want to check, okay, what was the size of this Lena image? It was 256 by 256, right?
Yeah.
We can, I'll just modify this and move this block. Okay, so I'll run this. You see first here the size of the okay, so you see 256 cross 256 is the original size of the Lena image. I have converted it already into grayscale by using this argument. Okay, now I'm resizing it. Now for resizing, I am giving the lower dimension, that means half of its original size. You see that this has already showed the size of the reduced image. Okay, just in case if you want to show CV2, I am show Lena small. Okay. You see this? This is a small image, a reduced image. Okay. Now you have the resizing operation to enlarge the image to double the size. Although I have not used any of the interpolation methods to it, maybe I can use CV.
It told me to collect.
Yeah, CV dot. You see it is automatically giving the option for cubic interpolation. I can use this and then Lena large. Enter. You see now you have got the bigger image. Okay? That's how you can resize it. Now you can play around with this interpolation method. You can convert this cubic to linear. In linear you will see more pixelated information around the edges because it tries to connect between two pixels by a linear function. Whereas in cubic it tries to fill the intermediate pixel by a cubic equation.
What is this, sir?
This is resizing.
Oh,
Resizing
okay,
to a
done.
smaller and a bigger dimension.
That's
Okay, using one of the interpolation methods.
interpolation.
Now how to draw something on the image? You have this dot rectangle and dot put text.
Yeah.
Okay. Now this is the input image. This is the starting location x comma y. This is the end location x2 comma y2, and this is the color of the box by which it will be drawn, and this will be the width of the box, the marker. Okay. So let's see how it will be. So you see, this will be the yeah. So this is the box which will be drawn, but it is showing that it should not be. Okay, let me use this. Where is the color image? Yeah. So let us use. Okay, you see this now? Now, why is this green color marker? Because this is red color. This 0 means red. 255 means green. I mean the second argument is green, and this is blue. Now, for example, if I want to have a red marker, I will say 255 here and 0 here. So this is BGR. So R has the 55 value, so it will draw a box with red color.
What is the tool, sir?
What is the thickness of that box?
This is the thickness of the line. If I make it as 5, it will be a very thick marker, like this.
Pixels.
Yeah, okay, thickness of the line. Similarly, you can put some text, for example, the same image and some text, and this is the starting location from where you want to start writing. Okay, this is the font, you can change the font and so on. So that has already been shown here. Hello world. Some of the arithmetic operations. Sorry. Clear? Yeah. Okay. Some of the arithmetic operations here. You have this image 1 and image 2. Let me load it.
That is for superimposing one over.
Yes, yes. So the CD dot add is the trivial addition between two matrices. It just adds together, and this add weightage is the operation by which you can give the weightage to one of the images. Okay, so in the output you will see the dominance of this particular image more compared to the second image. Okay, because its weightage is less. And subtraction is nothing but subtracting two different images. I will also note that there is this diamond and star image.
Is that how you make it foreground, background?
Segmentation.
No, suppose you are having one image, you bring it to the foreground, send the other image back.
No, ultimately when you are at the image level, all it matters is the pixel value, right? When you are trying to add them together, it's only your visual perception that something looks foreground and something looks background. You are just adding the pixel value. Now if I run this block, you see this is the image after addition. It has this building thing as a separate image and the galaxy as a separate image. At the second, you see that the building image is more dominated because I have added more weight to image 1. Okay, and similarly less weight to image 2. And in the subtraction, this particular dimension has been subtracted from the star image, and that's how you get this. Okay. Bitwise operation. I have these two different images. Okay, so these are and or
Complement.
yeah. So I have these two operations: bitwise or and bitwise and. So this is how it works. Okay. Next is image blurring. Okay, this is one important thing. Yeah, you can see this. I have read the image as a grayscale, doing the Gaussian blurring, median blurring, and bilateral filter blurring. You can see its effect. This is the Gaussian blur, which is very bad in terms of denoising, but because it smooths out the high frequency information also from the image. This is the median filtering, and this is the bilateral filtering. Bilateral filtering is one which is more preferred over all other filtering techniques, all the techniques. You can play around with this by varying the filter size and filter mean value. Similarly, these are the two different values for varying the how much of information, spatial information you need to consider when you are doing the bilateral filtering. It combines both the spatial as well as the color information from the array. This is image transformation. Yeah, you see this is a translational information, a translated image by 10 pixel in the x direction, 20 pixel in the y direction. This is a rotated image by 30 degree. This is a shear operation in the x direction by 7 mm. Okay, so all of these are there. You just have to properly manipulate this M matrix and accordingly to apply onto the image matrix. Edge detection. Okay, so these are the two, candy edge and Sobel edge detection. So candy is more preferred because it somehow tries to get away with all the weak edges into your image. But however, Sobel also you can use it. Like I said, you definitely can use these ready-made functions, but it's always good that you understand the logic behind how it is done. For candidate detection, ideally there will be a 3x3 filter with there will be two different filters. Like I said, there will be a Gaussian filter applied, right? So it will be 2, 2, 2, 1, 1, 1, minus 1, minus 1, something like this to identify all the horizontal edges, and the other matrix will be something like this. So it's better if you understand the logic behind all of these. Next is morphological operation. I have taken the star image. First, I have eroded it. So you see that the thickness. One second. Yeah, first I have done an erosion, then dilation, then this is called the open operation, which is erosion followed by dilution and opposite of this. So this is erosion means you see little bit less. The edges have little bit moved inside. Here a little bit dilated. Yeah, so all of these operations. You can closely look at these things. Next is image histogram. So this is okay. This okay. I was using the star image. So since there are only two color pixels, one is black and white, you have the histogram where the frequency of the black pixel is highest and the frequency of the white pixel is lowest, right? And rest of all pixel values are zero. That's why you see only two modes here, one is black and one is white. But if you look at the cameraman, you see that the histogram looks something like this. That means you have something each edge is black because it is wearing the black coat and the black canvas and so on, and some white representing the buildings and some background. Okay. Now, since looks like the histogram is not equalized, you can use the histogram equalization to equalize the histogram levels, so that after equalization the image looks little brighter if it's darker. Similarly, other way around, if it's brighter, it looks darker after the equalization. And this much I had to show, but we can discuss more on this.
So I thank Dr. Sabathiseri sir for giving part as well as providing the answer. Anyway, we'll be sharing this slide. Thank you.
Thank you, sir.
So now we can break for lunch. All other presentations are already available. Now we will see all. So one good thing is we try to cover
Yes.
Good afternoon, everyone. Welcome you all to yet another enriching session of AICTE under VAANI workshop. We are delighted to have with us a dynamic and highly accomplished professional in the field of artificial intelligence and software engineering, Dr. Madhusri Venkataraja. Dr. Madhusri brings a unique blend of academic brilliance, industrial expertise, and research excellence. She is currently working as a senior software engineer at Fujitsu Research, a leading cutting-edge innovations in AI. Beyond this, she served as the AI leader go-digit insurance, where her work earned her a place on the wall of confidence from the successful delivery of key AI projects like sentiment analysis. She has also contributed significantly to the tech ecosystem through her roles at NVIDIA as a solution engineer and as a PhD research scholar at Minima University, where her thesis focused on unsupervised video summarization techniques, a highly relevant area in today's AI-driven landscape. Her doctoral research was supported by the Vishwesvaraya PhD team of Ministry of Electronics and IT, Government of India. Dr. Madhusri has also served as an expert member of Board of Studies in the School of ECE at Reva University and has previously taught at institutions such as LJ Institute of Engineering and Technology and Vijayawardena Institute of Technology. Her academic credentials are equally impressive with a PhD in Computer Science and ME in Web Technologies, a PE in Information Science, all earned with distinction. In addition to her industrial and academic achievements, Dr. Madhusri is an active contributor to the research community. She has published in top-tier journals and serves as a reviewer for esteemed platforms like Elsevier, Information Fusion, IEEE Transaction on Circuits and Systems for Video Technology, and Springer, and many more. Ma'am, your journey is truly inspiring, and your deep expertise in both theoretical and applied AI makes you a perfect fit for this faculty development program. On behalf of organizing committee and all, it is my privilege to extend a warm welcome to Dr. Madhusri Venkataraja. Welcome, ma'am.
Okay, thank you for the presidency for the opportunity to talk to you all. So, do I need a mic?
Of course.
Yes.
Of course, madam. Ma'am, you wear it, ma'am. Wear it. No, I'm not sure.
I hope I'm audible now.
No. Let's reduce the fan.
Fan. Sir, fan.
No. Fix it. Yeah.
Is this fine now? Okay. Fine. Okay, it's been a long while that I use this mic, so that will take some time. Let's begin our session. Very good afternoon to all of you.
Good afternoon.
Okay, how are you sleepy or how's the situation?
Totally active now.
Totally
After
You're
having
hearing my
lunch.
voice.
After having lunch, no, our presidency we
That's
have provided
why
Awesome
I
lunch.
see that in your faces. Okay, let's make it interactive. I'll not give you a big lecture, and I'll talk about my project and what I've got in my slides. I'll discuss that. Please talk to me about what you are working on. Let's make it interactive. I'm also interested to know how we can collaborate and how we can exchange our ideas. So since this is a workshop on medical image or healthcare related, so I've taken examples of mostly healthcare. Let's dive deep into the session now. I had made one slide about me, but ma'am gave me a very good introduction. Thank you so much. So this is going to be the agenda for today. Since it is about healthcare, and in healthcare, what we can do as software engineers, we can contribute at various levels, but I have chosen today machine vision or computer vision. Let's understand what is vision first, and let's understand what is the basic of deep learning. And I'm not very sure how familiar are you with the topics here, but I'll give both the basics and some advanced ideas for you. Of course, I can't completely teach you some projects here, but I can share a few ideas with you. Let's again understand how deep learning is useful in medical domain. Deep learning is transforming every domain that we all know, right? But how it is useful in medical domain, let's look at it. And I was here on the topic of OpenCV. I think OpenCV is everybody's favorite here. Is it so? Are you all using OpenCV already? Okay, I'll not touch the OpenCV basics. I'll just show you how we can use for the project that we have chosen for today, the hands-on session today, how we can leverage it. And then last, I'll have few programs to discuss some things with you. Let's get into the hands-on after going through a few slides. Okay, let's begin now. What is vision? Before going to computer vision, what is vision? So, what do you see that image? What do you see there? Is that clear? Even in the back side? Okay, what do you see there? What is there in this green color image? Bridge? You see a bridge?
Bridge with water.
Water. Here.
Some
Plants.
plants,
Plants, green.
lotus flowers like.
Right? So, what was your sensing device? Your eyes. And what was your interpreting device? That's your brain. What you came up with was a description about the image. So, interpretations of the visuals that we see is called the vision. And what is computer vision? If a computer does these things for us. It sees, camera sees the image, and then a computer interprets what is there in this computer for interpreting a model, AI model. Earlier it used to be machine learning model, now it is deep learning model, some more. In future we don't know what else will come up, but machines are going to interpret the images for us. That is what is computer vision. So what is the goal of the computer vision? So if we have to change something here, because what we see is this kind of image. If I have to change something in that image, what I have to do? I have to play with these numbers. What are these numbers? These are the pixel values, right? This is what a computer says, and this is what we see. That is where we need a mapping somewhere. What we see and what computer sees. That is where our machine learning or deep learning models will help us understand the images. That is where computer vision happens. Not just images, videos are also coming into this, both images and videos. But videos are a next level problem because it's a sequence of images, right? There is a temporal order to the images. So we'll touch upon video processing also towards the end of the session. Okay, what computer vision can do for us? Any idea what applications you are already seeing? You're using already computer vision applications already? Sorry?
Image processing.
Image processing? Yes, MRIs. Yeah, you're gone the next level into healthcare. But let's understand the vision. This is computer vision for us. It can detect the face and it can detect whatever we want. This is a complete yesteryear's problem which is solved completely. You get program. This is a hello world of computer vision. detection, this is object tracking. This is also a kind of solved problem as of now. You get models, you get complete code, completely trained models. So all you have to do is download them, just pass your images or videos. Models can do this for you. But next level problems that we're still dealing with is this. What do you see here? Is this visible clearly?
Yes. Vehicle.
Okay, what do you see here?
A driverless car.
Sorry?
Driverless car.
Driverless car, yes, autonomous car. Do we need computer vision here?
Absolutely.
Yes. Oh, what type of visions?
360.
360-degree cameras. Okay, let me tell you, this is not just computer vision. Okay, there is other signal processing also because there are a lot of other sensors involved. But one major thing being used here is a 360-degree camera placed all over the car. It has to continuously watch and then detect objects, not just detect it. It has to take action based on the detected object. It can't go wrong here, right? What will happen? You would have heard of the news, right? The Uber autonomous car crashed and all those things happened, but still things are in place in the US and other developed countries. Do you see this coming to India anytime soon?
Yeah.
Yes? So it's in the news. It's in the news. Have everybody seen on the roads?
One startup there,
Yes, yes.
Mahindra,
Yes, sir.
even in our road, he has successfully implemented.
Our road.
Yeah, that means even in village or not, he has
Village is easy, sir. Here people drive in all directions.
No, for people, when he has implemented in India, it is really a challenge.
I know.
Okay, amazing. I hope maybe when our kids grow up, they may not get their driving license at all. I hope that day comes soon so that all the machines will be trying, no more human errors, no more shouting at each other. So Tesla is already here. So I hope it will grow faster. So as I was saying, there are many startups. I still see that in the news. I don't see it on the roads implemented because of many constraints of the environment we have, of the rules and of the road conditions, the environment conditions, everything. But we are progressing. So what is the key here? Accuracy of our visual models, object detection and tracking and everything. So this is still, as we see, this is already come to India. But next example I want you to look at and tell me, is this possible? Okay, first let's do this exercise. Please look at this and someone please explain what you see. One line.
First person is checking weight, I guess.
Barack.
And Barack Obama is something doing disturbing him. But putting it like, I guess.
See, this is not just a one word answer.
But
Right?
I
Yes,
think
yes.
that in Corona time we used to take some क्या भी बोले थे ना sanitizer. Sanitizer machine के साथ
Okay,
Yeah, actually the science is already ready.
but it is he's checking the weight.
Yeah.
It's a weighing machine, so maybe the graphic is hiding it. So the person is checking his weight, he's putting a coin and checking his weight. So the person standing behind is stepping on the weighing machine so that weight will increase. Right?
Disturbing, yes.
This is a simple scenario, right?
Yeah.
What makes it this image special is this is Barack Obama. He was the then president. President playing a prank is the description of this image, right? For us, it took a second, but we were able to arrive at it. But our models, can they do it? It's a big question, right?
Image caption.
You might want to go home and then find this image and check all the agents, ChatGPT, Gemini, everything. I have not done that yet. But this is my favorite image. I'm using this image from past 6 years almost in all my presentations. I'm waiting for a day when there will be some model or some level of technological advancement where this is detectable by a model. So that is where computer vision or machine learning models can do many things for us, but not the cognitive analysis of a situation. That is still a missing gap. Let's hope the gap fills up faster. So coming back to the applications of this computer vision, where all this can be revolutionizing the industries or our lives. First one is the augmented reality. You can see objects from nowhere coming to the face recognition, and then we have depth. Okay, some images are blurred out here. This is the depth mapping for based application, and you can use gestures. Instead of interacting with your computers or mobile phones directly, use gesture, and then text recognition. This is solved problem already now, right? You don't have to take our heads to get the PDF to Word or scan everything. That's the solved problem. And second is active IR camera. So there are multiple levels of applications. So before going ahead, let's look at a little bit of history. So how we started. See, this computer vision problem existed from ages. People started looking at it from 1956 almost. That is when artificial intelligence was formed. The term was coined at that time. And in 1959, neuropsychology and discovery of vision of humans, how humans see, how at least the animals, mammals, how they see images was understood. That understood that it is hierarchical. I'll come to this point later. And then first computer vision project at MIT was designed in 1960s. They were trying to identify the numbers, written numbers. Have you seen MNIST dataset?
Yeah.
Yes, some of you have seen. MNIST is a famous dataset of for optical character recognition. A character is written, image is taken, machines do recognize the image, which letter is there. And then around in 1970s, there was an AICTE, nothing happened there, no progress there. And suddenly in 1990s, some neural networks started developing. So people started looking at the neural network also as an option. Even though neural network was there since 1950s and all, but people started understanding neural networks more, better, and they started applying it. Until around 2001, some face detection kind of algorithms were there already, but they were all using the traditional approach where we have to extract the feature, and train a machine learning model, all that was happening. And in 2012, something magical happened. I still remember reading those things in the news then. AICTE won the ImageNet competition. So, do we know what is ImageNet? Any one of you worked on that?
It is a data set which has 1,000 classes.
Correct. It's a big data set. It is the standard data set developed by Stanford University. So, in collaboration with other institutes, they created this data set and they created a competition also. Like it is handled by Table now, but that was the competition. Every year people used to participate. You could also be participating in some of the competitions like that already. But one thing happened in 2012 was a neural network based, CNN based model won the competition and it was all-time high accuracy. So that is where everything started. You started seeing those applications coming into your phones and your laptops, and it started invading our lives. That is the success we got because of this AICTE one, and it was a deep learning model. So what is deep learning? It's the creation of machines which use the techniques that are inspired by our way of learning, human way of learning. How do we learn something? Or how do you teach a 2-year-old kid how does a cat look like? So when there is a cat in front of the kid, you show the kid this is cat, right? If you have a kid at home, you would have already done this. So how will you teach a kid to recognize something? Tell features. Do you describe features? No.
Keep
The
training.
traditional ML method, we don't do that. DL is our way of learning. So when there's a cat going around, you say, see, there's a cat. Okay, you do that 2-3 times. Third time, maybe the child will only recognize there's a cat there, right? But someday this might happen. A similar looking dog might be passing. The kid might say, it's a cat. What will you do? So correct. Reinforcement of no, this is not cat, this is the dog. So the child learns this is cat, this is dog. But you are not explicitly defining the features. Explicitly defining the features and training a model is what's called machine learning. deep learning brought that revolution. That's what I wanted to say here. Until recently, few last decade also, we did not have simply enough data or the processing power to train those deep learning models. That is why we were lacking, even though technology existed from a long time. Now we've been using these terms, artificial intelligence, ML and deep learning, a lot, right? How they're interconnected. AI is a complete big domain where it is there since 1950s. Even some basic neural networks were available at that time. Machine learning is a category of these AI algorithms, and that started beginning at around 1980s, and they are still being used. And deep learning is a subcategory which is driving the breakthroughs. How does a traditional perceptron look like? This is a traditional neural network. You can imagine a lot of wires. That means it's really old. So what used to happen there was, so if there's an image, you have to hand up the features and then give it to a classifier. Classifier can be a machine learning model like this. Should be artificial neural network or support vector machine, whatever it can be. So in this approach, what are the issues? Typical domain is first. What will you do if you want to classify medical images? How will you extract features? You don't even understand the medical images, right? Even after working so much in this deep learning domain, I can't read medical images because it's all domain specific. And it is time consuming and it is error prone also. You can't come up with a logic that will fit all the images, all the categories. No, it's not possible. And it's not scalable to new problems. So I extracted features for car recognition. Will it work for catwalk classification? No. So car features have to be car features only. So that is when deep neural networks or the deep learning models came into picture. They learned the feature benefits. So when I say features, what do you understand? Do you understand image features? Anyone can you explain me what are features?
Like for a cat, pointed ears and certain texture and depth of, so
Color, texture, shape,
Shape.
entropy.
Okay. So when we look at the image as image, we come up with this physical attribute that what we see, what computer will see. The matrix of numbers. And if there is a pattern in those numbers, it's a picture. For example, vertical edge. I'll show the example for that. So I wanted to understand what are features. We are not arriving at the features, we are just giving the image and saying the label, it's a chart. The machine has to learn the features. What is good about this? You can learn from the data itself, you don't have to teach anything, and you can easily extend to other domains. That is where ImageNet came into picture. ImageNet had 1,000 classes. Can you imagine what all it had? So every object that you see around was there as a class label in that data set actually. So it can work across many domains, and then it can be speeded up with GPUs. That is where the breakthrough came in. Machine learning models were there, GPUs were there from a long time. Somebody came, like mostly it was Andrew and team in Google or Baidu at that time. They came up with this idea of using GPUs for deep learning model training, and NVIDIA also invested hugely into this kind of research. They were only into gaming earlier, and they started showing people, see, if you have a big model which can give you better accuracy, train it on a GPU. That is where everything started. So look at this. Deep learning is equal to learning hierarchical representation. So one more question I have for you all. When I say deep learning, how deep it should be? What do you mean by deep? Hidden layers? After how many layers do you say it is deep?
Minimum one, max left to the problem statement.
No, after how many? Minimum one also you can say deep?
Minimum we should have a hidden layer.
Hidden layer. One input, one output, one At least one.
Can I call it a deep or it should have more layers to be called a deep? Okay? Then keep adding layers. Okay?
One hidden layer means maybe it is shallow.
Okay?
I think simple.
Simple,
Simple. Same.
Okay, I understand. I just brought this question up to make sure. So deep learning doesn't mean the depth of the network. That shallow deep we always talk about, that's different story. When I say deep learning, it's learning the hierarchical representations in the image. So the features of the image can be divided into three categories: low level, medium level, and high level features. And those features, if I have to sit and write a code to extract those features, it's extremely difficult. But a model can do this. These are the low level features. These are just the edges. Horizontal, vertical, 45-degree angle, edges, all the edges. And the next mid level feature will look a little bit like the object itself in the image. And the high level features look exactly like the object that you want to recognize. So this way of learning is inspired from the mammalian visual cortex, which is hierarchical. That is the concept applied here. So in a convolutional neural network, traditional convolutional neural network, we learn features. The model learns features in hierarchical way. So what happens in deep learning is, so you have an untrained neural network model. You do the training with a data set, and you use a deep learning framework to train this model. This is a model which is being trained to recognize cat and dog. And then once the trained model, this model is updated with its weights because of the images that it passed and trained. And once the trained model is ready, you can pass any new data, it will recognize. This is the philosophy, how deep learning works. So most of you might already know this. Just in case if you are new to this domain, I thought I'd explain this. Let's get into the types of problems that we are solving in deep learning. Here I have listed out the input types. Can be text, images, video, and audio. One thing is missing here is the sensor data. Any kind of sensor data you can signal. Basically, any signal also you can process. And now the first question is, if I ask a question, is it present or not in the image or the text? Or let's take the image example as of now because we're talking about computer vision. It will be a detection task. One example can be a cancer detection from an MRI image or a CT scan or X-ray image. Then, if I ask a question, what type of thing it is? We are doing a classification. Next thing comes is tumor identification. So if it is a benign or a malignant or any other normal scenario. So you can classify it. Next question you can ask is to what extent it is present. So here we are talking about the segmentation problem. Segmentation example is finding out the size of the tumor from the image. Nowadays it's very precise. The accuracy of the models have very much increased, and understand the shape of that tumor also. Next, what is the likely outcome? What do you predict? So prediction is the next problem that we can solve using deep learning. We can say what is the chances of survival, probability of survival of the patient. Then, what will likely satisfy the objective? Recommendation is the next level of problem that deep learning solves. Maybe we can recommend a best therapy. This is how the tasks are divided. What are the main challenges that we face nowadays? So data scientists face this major problem. There's a new model every day. How do I keep up with the trending models? So this happened to me during my PhD also. There was a mandate on journal publication, so I made a model, I trained it, and I published results, sent it to a journal. And it took some time, almost 1 year of time to publish. By the time it got published, it was obsolete. Nobody was using it anymore. Because newer models had come up. I had used the traditional ML things for the deep learning. And then this latest algorithms are rapidly evolving also. Today there is a new model. Tomorrow somebody will publish a variation of the new model. And there will be hundreds of variations. It's very difficult to keep things with. But maybe with the agents, it is a little bit better right now, but the problem is still there. And then fastest training. It's very difficult, especially for computer vision problems. You need bigger computation powers, right? You can't train very fast. If you want better accuracy, you need to train on bigger data, bigger model. The training becomes very slow. That is one more practical problem that we all face. And then deployment problems. So finally you got the results, you want to make an app out of it or deploy it somewhere for somebody to use. Where to deploy? Computation is also very costly. So that costing is also an issue. We can try to solve these things in our permissible limits. Let's look at the deep learning techniques. I'll start with convolutional neural network. So this is a neural network features, CNN features. There are low-level features, mid-level, and higher-level features. You can visualize them and see the faces detection model learns to detect faces and some facial parts, but low-level features for faces, cars, elephant, shape, everything is same. So there's one more advantage from this way of learning. What do you think it is? Clue is it's all same for all the categories. So very big advantage. You can reuse the features. The model, so we are talking about number of layers, right? So you train a model to recognize faces. Done. But now you have a problem to recognize cars. Do you train a new model from scratch? No need. Just chop off the higher layers, train only the higher layers, but lower layers will remain the same because they learn the same thing. So this is how a convolutional neural network looks like. So you have an image, you have convolutional layers, and you have max pooling layers. And after a series of convolution and max pooling, what will happen? Higher layers will learn the good features and it will be able to classify things. So this is how convolution works. So what goes behind? At the mathematical level, all the layers is one neuron. We take all the weights and then sum it up, add a bias, activate it, and then move it forward. This is one node in the neural network. What really happens in convolution is this one. We convolve a filter over the original image, and then we come up with this kind of this I use just to understand what happens at the pixel level. We just convolve a filter. These filters are learned by the neural network during the training process. Next category of models are recurrent neural networks. Have you heard of it or worked on this earlier? Anyone? Most of you have done it. Okay. So recurrent neural networks take the temporal order of the data into consideration and they remember things, they remember what happened in the previous iteration. That is why they can connect between the steps. So they're great for videos. And they're very good for text data also because they could remember the previous words, whatever we fed into. But next reformation happened with this 2017 paper. Attention is all you need. Transformers. Majorly, it was originally they started it with text data because textual understanding, text-to-text classification or translation was a bigger problem. That is where you need to make sure your model remembers what was the previous one, right? So that is where transformers were very good at it, and people found out a way to do this with vision also. These are the vision transformers. What happens in vision transformers? We take the image, we cut into pieces, embed it, create an embedding of all the pieces, pass it to a transformer. Transformer is a collection of two parts, encoder and decoder. Encoder learns we use a concept called attention. Attention understands the connection between the input image pieces. So now transformer encoder understands the image, and then you can have an NLP, that is multi-layer perceptron, to classify at that end. So this is our vision transformers. So using all these things, what all we can solve? The final problem statements boil down to one of these things. First one is the semantic segmentation, where each pixel is assigned a class label. And next one is the classification of the localization. Classify the image and also find out bounding boxes for the objects that we need. Here it is single object. Here you can have multiple objects for that matter. Object detection and tracking comes in the video part. And this is instant segmentation. Instant segmentation we perform object detection at the pixel level also. So this is about the basics. Do you have any questions here? No? Okay, let's quickly complete few more slides and then get into the coding part so we can all enjoy coding there. So what is deep learning doing in medical imaging? As we know, deep learning is revolutionizing all the industries, but one major is this medicine or the healthcare industry along with other internet services, media, security, autonomous machines and everything. But medicine is the major part. Here, I don't know if you can see, healthcare is the second largest market influenced by computer vision. How AI is helping in healthcare? First thing, image analysis and interpretation. What types of images you all know already. So if you have the enhanced image analysis, AI's ability to understand those images and predict diseases for us is increasing day by day. Second advantage of making machines understand and recognize the images is it is reducing the human error. Have you seen movies where the test lab reports were interchanged for cancer patients and all those? Maybe after this, such stories might not come. So, second thing is operational efficiency. How operational efficiency can be increased? Because these machine learning models are faster than the humans. Because even today in India, we don't have enough doctors or enough radiologists to read all the X-rays, right? So the human process is slow, but machines are faster. Next thing is cost effectiveness. If you can train a model and deploy it in multiple places, it is still cost effective, right? So it is faster and cost effective. So third thing is, it is helping us with predictive and the personalized healthcare. Predictive analysis is historical data analysis, either for a person's history or a community's history. Yes, we can make it customizable. Imagine you are logging all your data through your wearable devices like watches or rings or etc. But is that helpful for us? Can somebody sit and read and find out things? No, right? But if it is automated, machines can understand. I recently read a news where a lady was observed, she was always using her Apple Watch, she observed aerodynamic heart rate from past 3 days. So she went and checked with the doctor. They immediately intervened and treated her and she was survived. These are the few patterns that we see before a major heart attack. So that is where personalized healthcare is useful and predictive healthcare also. Nowadays, many people are getting into predictive. Before getting a disease, we are going for a predictive health checkups, right? And next thing is clinical decision support. We can provide assistance in the complex procedures, providing precise imaging to the doctors while doing surgery. Where is the exact tumor? So there are machines helping with that. And integration with other technologies, combining the AI technologies with the electronic healthcare records or the comprehensive health insights, that is definitely helpful. Today's focus is only the medical imaging part. We are not looking at other aspects of AI in healthcare. Majorly, images, X-ray, MRI, ultrasound, and CT. Then one more category is the normal images also, right? Normal images of the video recordings during the surgery or the surveillance of neonatal ward. Have you seen that neonatal ward? There's these small babies, and every bassinet has a camera attached to it, and if a baby cries, can trigger an alarm. So that kind of normal image, RGB images can also be come under this one. So in computer vision of healthcare, these are the four main different tasks. One is the entire image classification. This is the object detection, only a part where the human is detected. Now we have semantic segmentation and we have instance segmentation. What we saw for the general images, this is for the medical images. So today's topic says it is OpenCV. How OpenCV can help us with medical images in three categories. Radiology. Radiology includes all those MRI, CT scan, X-ray, and all those things. And surgery. So we have surgery. There are multiple types in surgery. 3D anatomical reconstructions or surgical planning, image-guided surgery. One more thing I was adding here is the surveillance of the surgery itself. There are 24 hours of surgery. So nobody can watch it, right? Nowadays all the surgeries are being recorded. So one more part is that. Next one is the pathology. Pathology involves detection of abnormal tissues or disease diagnosis report. From the symptoms you can diagnose what is the disease. All those things come under this medical field, these applications. OpenCV can help us mostly with all the vision problems, or the image processing problems also. Convert it to a different format of image, or resize the image, or any image processing you take up. Clarity, improve the clarity of the image, all those things come under OpenCV's domain. So today we are focusing mostly on DNN part of the OpenCV. OpenCV is extensively used for image processing since beginning, but nowadays people have started looking at the DNN, deep neural network part of OpenCV. So what all it can do? So this is a OpenCV DNN module is a part of the OpenCV computer vision library, and it enables model inference for deep learning tasks. Highly optimized for CPUs, and they're claiming that it even runs faster than on CPUs than the other frameworks like TensorFlow. Let's see in the lab, the hands-on session, we'll experiment on that. And then it supports various frameworks. Other famous on the frameworks are supported here. So what is the typical workflow of OpenCV DNN model? Load the pre-trained model. Either it can be TensorFlow, OnX, or cache models, import them, and then perform the image processing, resize, normalize input. This is much necessary because your images might be of all different sizes, and it is very important to normalize your inputs for the model to perform well. So this is the image pre-processing phase, and then we do the forward pass. No backward pass as of right now. It's only the inferencing, make predictions on the images or the video streams, and then we can do some post processing where we draw the prediction boundary boxes, or we can visualize the results in the image embedded itself. We'll see all those things happening in the hands-on session. So now one question comes to my mind is why use OpenCV DNN when there are so many other frameworks available, right? First one is the simple unified API. Okay. Am I audible now?
Bit close you, ma'am. No, ma'am, this mic.
Is it okay now?
Bit closer, ma'am, this speaker. Mic. Bit close.
Ma'am.
No.
Is it okay?
That is fine. This mic.
Can I change it to the previous setting?
That is fine. That is fine.
Okay, the speaker is being used. Is this the way it is?
It's fine, ma'am. Yes, from there.
Okay, let's continue. Okay. Why we use OpenCV compared to other frameworks? It is simple unified API for loading and running if you have pre-trained models. It is faster also. And you don't need a bigger GPU for running faster. It is optimized for many CPUs right now. It's ideal for edge devices, like if you want to prepare a model on an Android phone, you can do that easily. And it supports diverse tasks like classification, object detection, segmentation. You can work with text or any image data or anything. So, what are the capabilities of this PNN model? Classification, object detection, segmentation, text and face detection, pose estimation. There are many things here. And OpenCV's documentation, if you go to, it has everything that you need. You can easily learn, but you should know what you need. Exactly. So what I did was, I trained something, I had a model and then I prompted a agent to give me the OpenCV version of it that came easily. So you can follow that procedure as well. So next, performance. So they're giving this result, they're claiming that OpenCV is faster for many of the tasks. This is just to show that OpenCV is faster. Even I didn't know, I have not used OpenCV much for model training or inferencing purpose. Because the human tendency is how we work. I train a model in TensorFlow, mostly I inference also using TensorFlow. Or if I want to put it somewhere, I convert it to ONNX model, or if I am using PyTorch, or many other options are available for me. But after I got to know about this workshop is happening with the theme of OpenCV, then I started exploring more. I found out this results are actually inspiring. Let's see how faster it is. So let's take a look at the first problem that we are going to solve in hands-on today, that is the image classification. So this image classification follows this trend. We load the class names, we load the pre-trained model. I hope you are aware of what is a pre-trained model. Everyone? Okay, so then read the image and then pre-process the image. We can set the draw as input and then we can run the forward pass and then we can get the class label and the confidence score and then we can annotate the result and put the output. So this is the overall view. Okay, let's get into the hands-on with this problem statement now. So what I want you to do is, I have shared 3 Jupyter notebooks with you all. I hope all of you got access to it. And I have shared some text images. I could not download or share the training images that's there in the laptop, but I'll share the link with you all from where you can download the training images. It's not very big. You can also download and try. I will be showing my environment. Unfortunately, I don't have Colab. I'll be using my laptop's Jupyter notebook, installed one, and I've installed all the packages required for that. But if you are using Colab, you have to upload those IPY notebooks to Colab, and also the test samples. You don't have to upload everything. Just for your understanding, upload few images, and then you are good to go. And in Colab, if you get any error for any package, we will be using multiple Python packages, frameworks, right? Libraries. So if you get any error, just do pip install TensorFlow or pip install whatever CV tools. OpenCV must be there already in Colab. Let's get into Colab. I hope everyone is using Colab here. Is there anyone who is running in their local machine? Jupyter notebook in your local machine? Then you have to open your Jupyter notebook. If you are using Anaconda, you can use your Conda terminal and then install the packages. So let's start with the Colab. Let me know once everyone has uploaded their code.
We'll have a short break and then we'll continue.
Okay, maybe it will take some time for uploading also, we'll take a break.
We'll break for short break, very short break. Have tea and come soon. Anyone has not received the kit, please write as. Those are not, we have given one file, pen, notebook. Anyone has not received, please write as. One. Only one
Like this.
Yeah, like this. 2, 3. So 3 members are not received. Okay, so after the break, I will others all I will receive. Okay, thank you. Very short break. Okay, and then we come back. Okay, welcome back after the session. So we are almost to the end of the session. Just before the validation, we are coming to the last session. So where we'll be having the hands-on session on various deep learning. So most probably you know the Python. I believe that everyone know you might be very much familiar with Python. So we'll have an answer session. I believe that every data you have already downloaded to your site, right? So as and when man uses, you probably can try it. Otherwise, you can listen later on also. Yes, sir.
I hope everyone got the programs. Okay, let's start with the first one. So in that folder, you must be seeing the file called requirements. Okay, this requirements file, you see all these are the packages that you need for today's hands-on session. What you can do is some of them are already there in Colab. What you can do is if it is not there, if you get an error where, for example, pandas not found, you can do pip install pandas. For everything, pip install the package name. Hope that's clear. Everyone is on the same page with me.
Which file you have access?
This is requirements.txt. Or in the program also, once you see the code, you will understand. So for example, import OS will be default, it will be there. Import log, you might have to install. IP, image, pandas. So all these things you might have to install if it is not there. Why don't you do one thing?
The majority of this libraries they already installed.
Most of them are already there, then we'll begin. So initially what I do, I'll explain the code once and I'll give you some time to execute yourself and hands-on. So I do that, I do that. So 1 second, what I wanted to show you is this first block in the model training IPYNB. Okay, let me explain, I'll do that. Yeah. I just wanted to show you the block, full block. Okay. So this is the first block. And let me give you a brief introduction about what we are trying here. We have taken few breast cancer images, ultrasound images, and then we are classifying them into 3 categories. One is a normal image. Second one is if there is a tumor, benign or malignant. 3 classification on the medical images. The data set I will also show you. If you have time and if you have internet connection bandwidth, you can download the training data set. I will give the link and train yourself. Otherwise, I'm given you a model also. Then you can just load it and then do the inferencing on the test images that I have shared in a different email.
Madam, we only have the model evaluation.ipython. We don't have the other files.
So there are first one, model training.ipynb. So in this we will load, we will train a model. Second one is the model inferencing. Third one, how we can deploy it using Streamlit app. There is one thing called streamlit.py file. You just check if you have received all of them. And after that, one more thing I do. How do we use this model in OpenCV the OpenCV. You will do the training in TensorFlow. TensorFlow is also very famous framework for deep learning models. Let me begin. Try to focus here a few minutes. I take few minutes, maybe we'll wind up at 4 o'clock. So 10-15 minutes I'll take your time to explain the overview at least, and then it will be easier for you to run by yourself. So the first one. The first one is the model training.ipynb. It is not visible here. You can open your code. Code is already with you. You can follow there also. So first job is the required dependencies. We are importing all the packages that we need. Once we have imported it, we need to read the data. Okay. Data set I have downloaded already. Data set looks like this. Let me show you. Since I have not given you the training data set, this data set has 3 categories: benign, malignant, and normal. 3 classes. Something like this. So this is the data set. How do we download the data set? It is the table data set. This is the one. I'll copy this link in PPT and share it. I've shared it with you already. So you can just download this. This is the data set if you want to do the training. I don't think you will have enough time for training yourself because it is little time consuming. Going with less efforts, you can still try. Download this and store it in the folder where I have this model training IPYP, right? In the same, if it is visible to you, this is my code, and in the same folder, place the data set. Inside the data set, there should be 3 folders with each category. Let's go back to the code, and I have to say training data is the data set. This is the path to the data set. Since I am in the, what is my current folder? Here. In my working directory, I have stored this, so data set is the path. And then using pandas library here, we are taking the file names. File names are read for the purpose of choosing the images, right? And file names also serve the purpose of class labels. That is how we have stored the data. So what are the categories for us? Benign, malignant, and normal, 0, 1. And next, directed paths for containing the training data. We get the trained files. Each file is fetched here, and then we shuffle them. I don't want my data set, training data set to be biased in one order, so I want to shuffle them. Randomize the input and extract the labels. How do we extract the labels? From where am I extracting the labels here? From the data set. From the data set where? So the folder names, right? Folder names are my data class labels. How many labels are there here?
3.
Great. So you can read the data. Both the files and the labels are mapped here, and training data is prepared using. We are preparing a data frame using the pandas. And then if I print the training data, it should look something like this. This is the path. For example, this is benign, and this is the label benign. So it has taken the folder path also here. This is the image name, and this is the label. This is how a data frame is prepared using pandas. And now if I want to visualize the images, so we can create a count plot. So let's create this count plot. How does this plot look like? So there are 891 benign images, 421 malignant, and 266 normal in the folder that I have taken. So I told you it's a small data set. If you want to download, you can try also. So okay, let's start with the collected data and the labels. Let's go to the structure. So this code block is just all the folders. What pre-processing we are doing here? We are setting the batch size is equal to 16. Can someone tell me what is batch size? Those who are experienced in modern training?
Number of images in one batch.
One batch, right? So image size we are setting it to 256 by 256. Number of channels. What is this now? Number of channels? RGB, correct. We have RGB images, and then image shape. We are taking the image shape, and then data directories, data paths are taken here, classes are the labels, and then we are calling the pre-processing image. Now is the time to split the data into training and validation test. So, do you understand how do we split the, why do you have to split the data? Train, test, validation, right? So, what is your usual ratio? You can go with 80-20. So, here we are going with 80-20, 80% training, and then rest is testing. Testing or validation here, basically, once I train a model, I want to know what is my accuracy. The validation set is exclusive of the training set, right? And it is exclusive of the inferencing set also. So, what is the difference, major difference between these two, train and valid test? If you have done already, major difference.
There is labels in the training set. In the test set, we remove that column which has the labels.
Correct.
And it has whatever you are predicting should match the why you are hold back, the held back why part.
So once we do this validation, we get a feedback, and that is being used for retraining. If I see validation accuracy is not so good, I'll go for some more retraining. Once we have this, we can further split the validation into validation and test. That is the purpose. You can just validate and then you can test it. Validation feedback will go into the model retraining, test will not go. And then this is the image data generator. It is calling the pre-processing imaging, and then this is going to normalize my images. What we are doing here is dividing everything by 255. What will happen here? Normalization. Whatever is your pixel values, it will all come under one range. Next is the convert the label column to string types, and we can create the train generator. This is something very particular to TensorFlow, where we generate the data. Same thing we apply for validation. So whatever we do for training data, we have to do exactly same thing for the validation and testing data. And if you have to display the class names, I've just written line to display it here. And then, so now is the time for iterate through the keys or the class names, find out the class names, and then assign the unique labels to all of them. So, for example, there are 3 unique labels, right? So, first label is the benign, malignant, and normal. So, this will be 0, 1, 2. Set the number of rows and columns for the subplot grid, that is, this is for this type of visualization. So, we are setting the grid values, number of rows and columns in the final output. So, these are the subplots. So, what we are plotting here is the training data. Let's see. So, this is the file name, this is the training data, and after pre-processing, this is the identified tumor here, but this is benign, and here one more, and some more. So let's go. We understood the data right now, and let's get into the model training part. Here is the base model. I have chosen the model as DenseNet 121 with its pre-trained ImageNet weights. It was pre-trained on ImageNet images, but never on medical images. So we have taken those weights, so it is easily downloadable, it's preloaded already, and we are going into layers of this model, and this is the sequential model. So once we have this base model, we have to flatten the output of the base model and then add some more layers to it. So we are adding dense and dropout layers. These are the layers for classification. So over the DenseNet 1-to-1, what we did, we added a sequential model like this. We added layers. So what are dense layers? Anyone was worked on this?
Ma'am, fully connected layer.
Fully connected layers, exactly. And then dropout layer is what?
Remove the layers.
To avoid overfitting, one of
They are the regularization layers to avoid overfitting. They drop out, if I say 0.5, they drop out 50% of the neurons. So if you print the model summary, it should look like this. And then here I use simple visual Keras thing to visualize how it looks like. And I'm storing this this model after training as model.keras. You can use H5 extension also. And then here we have checkpointing up to what extent we need to train. We need to compile the models before training. We are using the optimizer, Adam optimizer, loss as categorical cross entropy, which is a good one for multi-class classification. Metrics we are using as the accuracy. Anybody can define accuracy for us? Correct number of correct classes, prediction classes by total classes. Correct. Then is the time to fit the model. That means train the model. Fit function is called for training. So all this while whatever we had decided, defined, we are listing here. We are passing the train generator. Steps per epoch is calculated here. As the number of samples, epochs are taken as 5. I think I tried till 10, but 5 is enough. Validation data also, and then callbacks is the checkpoint that we created previously. So this, if I execute this block, model will take some time to train on its own. You can read through this. Once you reach the number of epochs that you have specified at the end, and it reached up to an accuracy of 1 almost. Validation accuracy of 0.8. So let's display the training history, how it was trained, what was each epoch, how the loss accuracy was calculated here. But if you look at this, validation accuracy reached 1 at 5 iterations. I think that's why I went back and changed it to 5. This is the trial and error process. Nobody tells you this is what you have to do for this model, this many epochs you have to take, this many batch size you have to take. It's all by intuitions you will learn, trial and error. You keep trying. So here if you see the trend, it kept increasing and it kept dropping also after some point. There are methods where we can say if it is not, accuracy is not improving much, we can stop the training. So all those things are available in TensorFlow, you can explore that. Let's evaluate the model. So it is the time for us to call the predict functions or evaluate it. So once we evaluate, this block is going to evaluate for me, that is train, how much we got, 93%. In validation we got again 93% accuracy. We tried with evaluation data set that we created again. So we can plot the loss. So once the train history and the validation history both have this here. You can plot training and validation loss. Blue curve is the training, orange one is the validation loss. So first one looks very nice, well trained, and it hit a plateau. It was not decreasing. Loss was not decreasing after some point. You can observe that here. So if the gap between this training and validation increases, this is called overfitting. So now I have training is complete. Now what name I gave was model.keras. This is gone and stored in my folder. Let me go and evaluate it. Let me load this model and find out. Same import statement. Let's take the same thing. Whatever we did for training data, we will do the same thing for testing data. All the data generator and the image processing or image transformations, whatever we did, everything we will do here again. Coming to the actual evaluation part, we are defining the class names, we are calling the models predict function, and then once the predicted labels, we have to take the argmax of the prediction because we have three classes. All the three classes are predicted with some probability. We will take the maximum probability, and I will get the true labels. Since it will show 0, 1, 2, we will not remember what is 0, what is 1. So we will map it to the actual names, and then we can plot a confusion matrix also. So here is the confusion matrix. Quite good for very small number of training data that I have taken. The overall accuracy is 71%. Do you see the drop from training to testing? Because it's the smallest data set, right? So this is where what is overfitting. You can use methods like adding more data for improving the accuracy. And then we are making predictions for few images have hard coded here, and then I'm passing them into the model. So this one, the first one, is actually a malignant image and it is predicted as malignant also. So this is correct. So here we are comparing. Where is it? Class level predicted labels. We have to compare with our predicted and actual class labels. So most of the times it is correct. I saw some incorrect classifications also. So this is how what we did was in the training phase we trained a model, saved the model, and then in the evaluation phase these two will never happen in the same phase. You train a model, you evaluate and then deploy it somewhere, and somebody else will be doing the inferencing for us, right? So that inferencing also we have completed here. So what we can do with OpenCV now? Coming back to the question of OpenCV. You remember my model name is model.keras. I am using TensorFlow again to load the model. So you know this TensorFlow and keras relationship, right? Yes?
Keras is a wrapper on top of it.
Wrapper on the TensorFlow. So it makes our job easier. Otherwise, earlier days TensorFlow was much more lower level library. So keras came up and then encapsulated it to make it easy for us. But now it is TF that keras will solve our problem. So what we can do here is, if I have real-time video input, how we can, let me try running this. It should work actually. So what I did was I created a video of all the test images that I had passed on to you. So that I stored as output at API. Yeah, it is running. Like this is 0, we are one class. I forgot to shut the okay. Other types is also come. So those images I converted into an API file. I passed it as for capturing the real-time video. It is video capture. Instead of the video file name, if you give your camera input, whichever is the device connecting to your machine, if you give that input, it will capture the live stream also and then perform the same thing here. What happened here is, in the previous evaluation script, we did inferencing for one image at a time. Right? One image was passed to the model, predicted one. Here, we are passing the video. Here, look at this. We are reading the frames in the video. This part is reading every frame in the video. Every frame is a one image for me, and that is yeah. I told you that everything we have to repeat. Resizing whatever because we applied, we have to repeat, normalizing and everything, and then we are predicting all the images in a while loop until the stream exists. So in my case, this is my official laptop, so I'm not able to connect the camera, but that's why I use the file name, video file name. I hope this is clear. Fine. So like this code part is helping me put the label on top of the image and then render it. One more good thing it is doing is for every step how much time it took. It is doing that. So while you are running this code, can you do one thing? Since we are inferencing with both TensorFlow and CV2 here, can you find out the time difference? What you have to do is just import time and call, so starting time is equal to time dot time function, call the fit function here or the predict function for both, either one of them, and then stop it. Now, how do we find out what is the exact time? Elapsed time or something like that is equal to stop time minus start time. This much if you do, you will know how much time it took for training. We are calling predict function in the evaluation script using TensorFlow, and in this script we are calling predict function again. So find out for each image how much time it is taking, so you will know which one is faster. So these are the three programs that I wanted to explain to you today. But once you have a model, obviously your end user might not be using the Jupyter notebooks, right? So what you can do is you can build a Streamlit app. Streamlit is for visualization. You can create dashboards and all those things. What you have to do is install Streamlit. I'm sure it is not by default installed. Pip install Streamlit and write a code. This code is very simple, and even if you don't know how to design the user interface for your this app will be opening in your browser. Even if you don't know how to create a visual very good web page, so you can use any of your agents and then make modifications there also. But I'm giving you a simple Streamlit application here. So what we have to do here is we can Streamlit run streamlit.app.py. I hope everyone got this file. Let it open in my browser. So here there will be a prompt to drag and drop or upload the image and then visualize everything is happening here. So this way you can deploy this web app also. It's much easier for rendering. So this will be useful if you are presenting your projects. Yes. So you got this. So what will I do? I will just drag something and drop here. Got the output, it's still loading. It is a little bit slower one, but it works well. Analysis is completed, prediction is benign, confidence is this much, and it is even showing me this. This you can use for inferencing. This code I have given, we will not have enough time to explain the code. If you have questions, I can answer that later. So these are the 4 programs I want you to explore today. Any questions here? No? Then go ahead and start with your coding. So one small thing assignment I am adding, which I have not added, is add the time, add a timer and find out how much time it is taking.
Placing it on the mountable drive or something like that.
That you can include, sir. If you want to keep it in a drive and load it, you can load it.
So this is the training one. Here it's giving
That is, Okay, good. Because the path name, data set, right? So you have to give your data set's path name. Did you download it, sir?
Yeah, few files I have to upload or something, right?
So one second, I'll display the training data if you download it later. So this is the training data that I have used. You can download it. It will be downloaded into a folder called dataset.
I have just taken it directly. I downloaded few benign, few malignant, few normal. So that directly is on my desktop.
Okay, so you have to categorize them into 3 folders, benign, malignant, and otherwise our code is written in that way.
Okay, so does it have to be on the desktop?
Or wherever is your code. This is the collab, right?
No, collab.
Upload it to collab.
Upload which one? All the images?
No, I'll just try. So here is a directory structure. So wherever is your training IPY in the notebook, in the same place and data set also. This is for training, or I can name it training, or you can name it whatever you want. Inside that there must be 3 folders: design, management, normal. Inside these folders there will be images, corresponding images with that file name. And here again you need to have test images. Again you will have 3 folders: design, this is how it should be. And I was talking about the model location, right? So model should also be model.js. You can hold this code folder completely into your collab once I have taken upload, because this needs to access this location, this needs to access this folder. If it is not in this folder structure, the code is written in such a way that read the folder structure and then find out subfolders for the class names. So you need to follow this folder structure.
So like for instance, with my IPV and V is, it's directly uploaded, right? See, I open it, and now I open it with my
Correct.
IPV.
Correct.
So
So here you have to upload.
you are meaning I open this, then I upload all the images here.
Yes, in that format.
So I have to create a folder.
Yes, that folder structure. Or locally you can create an upload. Create here folder structure and then upload accordingly.
And how many should I approximately give?
For testing, we can take 1 or 2. So if you want to do your training, go to the website, download the entire data set and complete.
So these images, I can use as
Correct.
so, this is the data set I'm having on all 3 types of images. So I create folders for
वीडियो को एक इमेज को एक वीडियो को एक इमेज को 2 फाइल में कंप्यूटर में भी कंप्यूटर कर अपलोड करें प्रोग्राम
Program है ना ये we are training evaluation ये model OpenCV 1 2 3 4
I have my data set folder on my desktop. So I drag the whole thing from my
Collab.
so then I have all the data set directly with the 3 types of images. Then I create a similar one for training.
Training, yeah. Training data you need to download from there. That website. So that's huge. I could not share.
Training is, so the one you have with all those images. That is what best.
The one I have shared is this.
Yes. So with our CPU, do you think we can play?
That was not very I showed the, if you open the training script, even displayed how many images are there. And what images is around 1,000. But it takes some time.
This is one with the GPUs or that sort of
It's not GPU. I7.
गूगल से कैसा कनेक्ट करो मैं बात कैसे हो तो तेरा पैकेज इसका था अपलोड करेगा तो डेटा कनेक्ट का वो हेड ड्राइव करना वो कहाँ गया
ये
हाँ वहाँ नहीं मालूम हाँ गूगल में काम
गूगल में मिल जाता है माउंट ड्राइव टूल है जो मेरा मतलब है
इधर तो क्या होम ड्राइव में हो जाता है
ड्राइव डॉट अब यहाँ से हम करते हैं तो दूसरा ये मॉडल ट्रेनिंग राइट अपलोड बोल रहा हूँ हम लोड में
डेटा सेट का वो डेटा सेट में पूरा अपलोड करके देता है
Space for
गुड
हाँ उनके बाद में इसको हमारे कल
हो तेरी
मजा करता
वीडियो वीडियो कैसा करें
नहीं करा उसने पहले फॉलो ट्रेंड करने
प्रिंट होगा नहीं अभी रन हुआ
विजुअलाइज करो डन सर
फर्स्ट कोर्स रन करें उसको
यहाँ पे टाइम होता है देन सेलेक्ट करो सिग्नेचर मॉडल
So if you want to inference or
Train the model train.
model outputs, you will have to run the training block fit function here like this. To run the training block, you have to download the data from this website.
पूरा केरस में
Once you download the data,
विजुअल
you will be
विजुअलाइजेशन
able to run the
पूरा
training
केरस
block.
में
So let me show you where the training is.
विजुअलाइज करना है फिल करना है यहाँ पे ट्राई करना है कितने को 5 जरूरत पड़ रहा है बेटा सिस्टम
So this is the training block that you will have to run to get the model. This will store the model because in the notebook in previous we have written model.keras name. It will be stored there. So you need to run this and then find out how the model is saved. To run this block, in the previous blocks I have mentioned the dataset folder name. There you have to download the folder. data set can be downloaded from cable website. So,
Sir, it is there, sir. That time only. I didn't do anything.
is anybody able to download the data set?
वीडियो का स्क्रीन
टेस्ट वीडियो आउटपुट डॉट मैम यू
वीडियो
हैव
फाइल डाउनलोड ईमेल में है ईमेल को अरे मैं डाउनलोड करें ना ईमेल में है वो इनोवे जैसा लोना कमाना उसमें वीडियो फाइल डाउन नीचे जाए हाँ ये भी है करता है जब वो डाउनलोड करो फिर ड्राइव में डाल दो कहीं चल
आउटपुट इसमें ये भी एक
वो अपलोड करते हैं
so show us the place one, place data.
वो हम डेटा सेट रखना है सर अपलोड कर दीजिए बाद में
डेटा सेट पे काम करना
हाँ
मैं ट्राई कर रहा हूँ
वो एक्सट्रैक्ट किया सर जिप में है वो फोल्डर है ना जिप में है तो एक्सट्रैक्ट करेंगे ना
मैं थोड़ा थोड़ा फाइल्स में डेटा सेट करके उसमें 3 कैरेक्टर करके एक्सेप्ट करना है डंप कर ड्रैग करके डाल दे
हाँ डालना
मगर ये नहीं ड्रैग करने को ट्राई किया थोड़ा
नहीं तो मैं ड्राइव माउंट किया था ड्राइव अपलोड किया
ट्रेनिंग वाला में ड्राइव किधर है टेस्टिंग वाला में
नहीं सर आपको ड्राइव में पूरा डेटा सेट देता हूँ वहाँ से मैं माउंट यहाँ पे नहीं रहना इसका प्रॉब्लम यही है इसलिए ऑलवेज यू हैव टू डेटा सेट इन योर ड्राइव whenever you want wherever you want
अपना
ये
ड्राइव
करो सर ये करो प्लीज कुछ बराबर कर रहा हूँ
नहीं
वेस्ट है वेस्ट
तो कितने महीने से एक ही चैनल की वही मेकअप का फर्स्ट
so this to learn go to Google just type how to mount the
package
Please let me know if you have any queries.
ट्रेनिंग किया
हाँ सर ये दो लाइन डालो उसको
इसमें तो डालिया क्या तो
क्या आ गया
क्या भी नहीं खाली
खाली फाइल ओपन करो
सर वो वीडियो प्ले
करते हैं इधर गूगल तो मॉडल सेव होता है
While you are exploring these things, I don't think you will have enough time today in this session to complete the training process. You can go home and then do it and then can come back to me if you have queries. I want to have a little bit of discussion with you all before we close because sir has gone to call the professor for valedictory. Before that, let me just finish. One more next step is the object detection. Once you know the flow, you can prompt this and get the code. That's not a big issue, right? So, but you should know what you have to do. So, using OpenCV, you can do this object detection in the same way. This I'll be sharing with you all. Same thing if you have to do it on a video, is the script that I gave you using OpenCV video captures. That one you have to use. Here I have tagged one more link here where you can download the video datasets. And I wanted to have some food for your thoughts. Now, after all this discussion, after you have tried your hands-on medical images, can AI replace the humans in medical field? That's one thing that we have to question. Now, do you trust if you go to a hospital and AI model is predicting your medical? Do you trust?
yes
Yes.
It's out of scale.
Okay, great. So it's a study 2024 showed that ChatGPT powered AI was outperforming the human diagnosis. Right? We are in that stage right now, and this trend continues to grow, where the AI healthcare diagnosis So in future, you might visit AI model instead of a radiologist, because in India we have a very big gap between the number of in India, we have a big gap between the number of radiologists and the number of patients. Especially TB is a big issue in India. Many patients don't recognize they have a TB and they go to the doctors at the last stage because they don't have a facility in the villages, right? So if we have a model, a villager can take a photo of it and then send it to a city doctor, we can do that. But it is not a debate of AI versus humans, but in future, the most promising future can be a combination of both humans and AI, where AI will enhance the images and will help humans predict better. So I wanted to thank you all formally now for listening to me patiently even in the afternoon session. Thank you so much. Let's stay connected. You can connect with me on LinkedIn. If you have any questions also on answer session, please post your questions to me. I'll be able to help you out.
Ma'am.
Ma'am.
होगा सर Actually, I wanted CV only. This model training is done. I just loaded the. For 2 minutes. I want actually this one. Because is fine. Just mount it, upload it in the drive. This yeah, it is around. Now here, I have to upload this model evaluation. How do you just to load the model, right? That's what model is not that far. Where is it? Here. Here, download this.
Okay, why don't you upload the page? Why don't you upload or download the Keras and upload? Either way. Wherever is your train or right, you have to find that for that I have that the same folder the name
Yes, this file is there. Model dot keras. Model dot keras. Save the date. Shall I put it right? Here mounted. Here also I mounted. Shall I put it right?
never done any projects in medical degree. No, try working on this
Test. The same folder shall I apply? Here. Select. this testimony to images is the path to the implementation.
But where you have to give the path for
Testimony is separate folder.
I made it empty path, but all because you have to put it. Or you can take some more images and put it in So those images I converted it to an API file. I passed it as for capturing the real-time video. It is video capture. Instead of the video file name, if you give your camera input, whichever is the device connected to your machine, you give that input, it will capture the live stream also and then do the same thing. What happened here is, in the previous evaluation script, we did inferencing for one image at a time. Okay, one image was passed to the model, predicted from. Here, we are passing the video. Here, look at this. We are reading the frames in the video. This part is reading every frame in the video. Every frame is another image movie, and that is yeah. I would read everything we have to read. Precisely whatever we proceed, we have read. We are correctly normalizing everything, and then we are predicting all the frames. While loop until the frames. So in my case, this is my visual output, so I'm not able to shine the camera, but that's why I use it. So while you are running this code, can you do one thing? Since we are influencing with both TensorFlow and CV2 here, can you find out the time difference? What you have to do is just import time and call so starting time is equal to time dot time function. Call the fit function here or the predict function for both. Either one of them. And then stop it. Now, how do we find out what is the exact time? Elapsed time or something like that is equal to stop time minus start time. This much if you do, you will know how much time it took for training. We are calling predict function in the evaluation script using TensorFlow, and in this script we are calling predict function again. So find out for each image how much time it is taking, so you will know which one is faster. So these are the three programs that I wanted to explain to you today. But once you have a model, obviously your end user might not be using the Jupyter notebooks, right? So what you can do is you can build a Streamlit app. Streamlit is for visualization. You can create dashboards and all those things. What you have to do is install Streamlit. I'm sure it is not by default installed. Install Streamlit and write a code. This code is very simple, and even if you don't know how to design the user interface for your this app will be opening in your browser. Even if you don't know how to create a visual very good web page, so you can use any of your agents and then make modifications there also. But I'm giving you a simple Streamlit application here. So what we have to do here is Streamlit run Streamlit.app.py. I hope everyone got this file. It will open in my browser. That you can include, sir. If you want to keep it in a dry and load it, you can load it. It was the data set, right? So you have to your data set. Download it, sir. Actually, the training data, if you download it. So this is the training data that I have used. You can download it. It will be downloaded into a folder called dataset. So we have to categorize into 3 folders. Otherwise, our code is written that way. So here is the directory structure. So wherever is your training notebook, in the same place add dataset also. This is for training, or I can name it train, or you can name it whatever you want. Inside that there must be 3 folders: design, management, modeling. Inside these folders there will be images, corresponding images to that file name. And here again you need to have test images. Again you will have 3 folders: design, this is how it should be. And I was talking about the model notation also, right? So model should also be model.js. You can hold this code folder completely into your collab, one by one so you can upload, because this needs to access this location and this task. If it is not in this folder structure, the code is written in such a way that read the folder structure and then find out subfolders for the class names. That's why you need to follow this folder structure. So here, in that format. ಮಾಡಲ್ ಇರಲಿಲ್ಲ, ಮಾಡಲ್ ಡಾಟ್ KRS ಅಂತ ನಾನು ಇಮೇಲ್ ಕಳಿಸಿದ್ದೆ ಅದರಲ್ಲಿ ಮಾಡಲ್ ಸ್ಪೇಸ್ ತೊಗೊಳ್ಬೇಕು ಇವೆಲ್ಲ ಸಿಗ್ತಾ ಇಲ್ಲ ಅಂತ ಅವಾಯ್ಡ್ ಮಾಡಿದೆ ಕಳಿಸ್ತೀನಿ. ಓಕೆ if you want to inference or see the model outputs, you will have to run the training block, fit function wherever it is. To run the training block, you have to download the data from this Kaggle website. Once you download the data only, you will be able to run the training block. So let me show you where the training is. Store the model, because in the notebook in previous we have written model.kera's name, it will be stored there. We need to run this and then find out how the model is saved. To run this block, in the previous blocks I have mentioned the dataset folder name. There you have to download the folder. Dataset can be downloaded from Kaggle website. This is the one. Is anybody able to download the data set? have queries. I want to have a little bit of discussion with you all before we close, because sir has gone to call the professor for valedictory. Before that, let me just finish. One more next step is the object detection. Once you know the flow, you can prompt this and get the code. That's not a big issue, right? So, but you should know what you have to do. So, using OpenCV, you can do this object detection in the same way. This I'll be sharing with you all. Same thing, if you have to do it on a video, is the script that I gave you using OpenCV video capture. That one you have to use. Here I've tagged one more link here where you can download the video datasets. And I wanted to have some food for your thoughts. Now, after all this discussion, after you have tried your hands on medical images, can AI replace the humans in medical field? That's one thing that we have to question. Now, do you trust if you go to a hospital and AI model is predicting your medical? Do you trust? Yes. Yes? Okay, great. So it's a study 2024 showed that ChatGPT powered AI was outperforming the human diagnosis. Right? We are in that stage right now. And this trend continues to grow where the AI can help your diagnosis. So in future, you might visit an AI model instead of a regular. Because in India, we have a very big gap between the number of in India, we have a big gap between the number of radiologists and the number of patients. Especially TB is a big issue in India. Many patients don't recognize they have a TB and they go to the doctors at the last stage because they don't have a facility in the of both humans and AI, where AI will enhance the images and it will help humans predict better. So I wanted to thank you all formally now for listening to me patiently even in the afternoon session. Thank you so much. Let's stay connected. You can connect with me on LinkedIn. If you have any questions also on hands-on session, please post your questions to me. I'll be able to help you out.
ಆಮ ಕಾಣಿಸಲ್ಲ ಪೋಸ್ಟರ್ ಕಾಣಿಸಿದ್ರೆ ನೀವು ಕಾಣಿಸಲ್ಲ ಲೈಟ್ ಫುಲ್ ಡೌನ್ ಆಗೋಗುತ್ತೆ ಅದೇ ಕ್ಲಾರಿಟಿ ಇಲ್ಲ ಮ್ಯಾಮ್ ಅದೇ ಕ್ಲಾರಿಟಿ ಇಲ್ಲ ಇಲ್ಲ ನೀವು ಎಷ್ಟೇ ಫುಲ್ ಮಾಡಿದ್ರು ಅದು ಕ್ಲಾರಿಟಿನೇ ಇಲ್ಲ ಅದು ಎಲ್ಲಿಂದ ಬರುತ್ತೆ ಆ ಫೋಟೋ ಆದರೂ ದೊಡ್ಡದಾಗಿ ಮಾಡಬೇಕು ತಾನೆ ಅವರು ಅದು ಪೋಸ್ಟರ್ ಬೇಕಂತೆ ಅವ್ರಿಗೆ ಎಲ್ಲಿ ಕಾಣಿಸುತ್ತೆ ಅದು ನಮ್ಮ ಪೋಸ್ಟರ್ ಕಾಣಿಸ್ಬೇಕು ಕಾಣಿಸ್ಬೇಕು ಈ ಕಡೆ ಒಂದು
So everything she was writing me, so I was disturbing a lot. She was frustrated about you. people were taking that as also he immediately transferred to our facilities and started training people. That's special. Even after reaching that, we don't want to explain the responsibility because I was so happy about that. So, actually, you know, even this case to bring 5 to 6 cases present, okay, it's almost a lot. Finally, that I want to try to the first session was actually Dr. Nora from the University. So he was taking a session on artificial intelligence and making process. Followed by the second session was taken by Dr. B. And he's from Uttamobile. So he really did a good job to make this session more interesting. The second day was taken by Dr. Ravi from Indian Anatomy from various biology. So I took all the things on the session. I believe that you will feel that the anatomy is very interesting from this session. And the last session was in morning to
participants, the audience who have been there continuously for 3 days, and I know you must have not more, but at least you must have learned something out of it, and which you would carry on to your classrooms. Thank you very much.
Anyone would like to share your feedback on AICTE
Yes, what internal or external? We can go.
Actually, though I'm still also and also external participant because I just joined recently, and I was really happy that this was the first FDP session I have attended in this university, and the external sessions was very enhancing and experiencing. Hands-on sessions was very good. We were practically able to do it and experience with the real-time data sets, and I have to really thank the entire team who have organized very well this event, and I actually would say this is a very great successful event. Thank you so much. What are the expectations from in future to further this kind of reason technology so that we will get as we know like knowledge transferring is very important. Thank you so much.
Thank you. External, sir, please, 2 words just. External. Madam, you will be ready after.
So